Right. I think we will start. So good morning, everyone. Welcome to this 156th edition of the Zak World of Façades conference series. My name is Ahmed. I'm part of the organizing team here at Zak. This is third edition in Kuala Lumpur. So I'll quickly take a couple of minutes to introduce our event partners and just give you a brief of the event history for those who are attending the event first time around. Okay, all works well. Right. So, we've been organizing the Zak World of Façades conference series since 2012. As I said, this is the 156th edition and the third one in Kuala Lumpur and Malaysia. We've present all across the globe from New Zealand up until Canada. And the events are very different in different parts of the regions because facades are designed, engineered, installed very differently in all those regions. In certain places, sustainability, low carbon, embodied carbon is the way forward. In certain places, it's about cost. Certain places, it's all about style, lavish, high-rise, complex geometry. So all our events adapt to the respective local region, local city, local countries' needs, and that allows us to bring innovation from one region to another region and vice versa. This is our event lineup in 2024. So we almost had 29 events in 21 countries around the globe. We're scheduled to have around 35 events in 25 countries for 2025. Just want to start by thanking our event partners and also introducing to them. All our associate partners have a tabletop booth outside. Please do meet them in the networking breaks or whenever you can. They all have unique products which would definitely help you in your projects. So I'll start with Cosentino. So Cosentino is a Spanish company. Their cladding product is called Decton. It's a new age, non-combustible, sustainable product, which is, I think, the way forward. I think moving away from our traditional composite panel, using these kind of new age cladding materials is the way forward. Same goes with Florum, an Italian manufacturer. They've also got an interesting cladding product, sustainable and non-combustible. It's a sintered stone, which was earlier used in interiors and now being used on the external facade as a rain screen application. Jotun is one of the global leaders in powder coating solutions. One of the leaders in this region in their domain. Kinlong from China, one of the leading glass hardware fittings, accessories, and a plethora of accessories for the door, window, and facade segment. Curare is the mother company of the laminated glass interlayer brands Throsiflol and Sentry Glass. I think they help in security, in ballistics, and other structural properties of glass. Rotoblast from Italy, they have a lot of unique solutions for facades, pacifier protection. They've got membranes and a wide range of other unique products which can seal and bond your facade. Coming to sealing and bonding, Tremco, again, one of the world leaders in sealing and bonding solutions. However, over here, they're displaying a new product for the region which they're launching, which is ETICS. It's another type of dry cladding system which is picking popularity. And then Trimo is from Europe. They've got, again, a non-combustible cladding solution in a different format, more metal-based. They are partnering with us in this region for the first time. And of course, Vectorfoil Tech. Vectorfoil Tech are our partners in this region and other parts of the world. They've got a fabulous solution, which is ETFE, which is very versatile. You'll be hearing from them later during the day. These are our associate partners, and I said all of them have a booth outside. Please do meet them whenever you can in the networking breaks or in the course of the day. I'll just quickly introduce our next few events which we are doing. So our next one in the wider region is in Melbourne. So it's our 4th edition in Melbourne and almost our 10th edition in Australia. There's a lot of connection with Southeast Asia and Australia. A lot of designers, a lot of curtain wall producers export to that part of the world. Our last one for our Southeast Asian series for this year is in Bangkok. That's on the 21st of November. And again, Australasia next year, we've got Sydney on the 20th of February, and we've got Auckland on the 27th of February next year. So these are our next 4-5 events for this region. And of course, we've got Singapore in March next year. We go back to Jakarta and we go back to Ho Chi Minh City next year. So this is what we do with the events. We bring people to tell stories, and today's presenters all have a different story to tell, the way they have designed or engineered or given solutions for doors, windows, and facades. And I hope you'll like today's agenda too. It's an interesting one. We're at a very different phase of the construction industry. I think there was a statement by our Honorable Prime Minister that no more high-rise buildings in Malaysia, at least the government won't be doing. We've had these kind of statements from other world leaders also in the past, but I think you can't stop construction going vertical, at least in a city like Kuala Lumpur, where you have space constraints. Vertical is the only option going forward. So it's a interesting era we are in, and I hope all of us will design safe, sustainable, and smart facades. We've recorded today's event, so all the presentations we've got permission to share with you. We'll send a YouTube link a week from now, and you can access that and share that with your colleagues. So that's it from me. I'd like to call upon today's event host and convener, Ms. Shin Kok. She's a partner at Facade Network. So she'll be hosting you until the end of the day, introducing our speakers and ensure they don't go over time, and also entertain you as the course of the day. So thank you all, and we hope you enjoy today's agenda.
Good morning, ladies and gentlemen. Thanks, Ahmed, for setting the tone for us today. And welcome again to Zak World of Façades, 3rd edition in Kuala Lumpur. Ladies and gentlemen, I would like to welcome Miss Lillian and Michael from Veritas to share with us the aspect of facade in terms of design to experience. Let's welcome Lillian and Michael with applause of a.
Thank you. Good morning. Great to see a big turnout. Thank you to Zak for inviting me again. I'm very honored to be invited again. And I thought I would share the honor with Michael Tan from our office, who has really been helping me on some of the buildings that I'm showing today over the last 10 years. So Michael has been with us for quite a bit. Just to correct what Ahmed said, the Prime Minister said not another tall building during his tenure. So it's during his tenure, because we have done quite a few in the recent past. I thought that was a wise statement, actually, but that doesn't stop us, certainly, because KL is a very aggressive building location. I think you will all, I hope you all will get a chance to see, though I heard Shraddha is only here for a half a day more, and may not have a chance to see all the things that has happened. I thought today I'll go through our journey of doing buildings, particularly building on the building facade, where when we started, we were always very focused on the performance of the external wall facade. And we will end with a story we call the Trio of Triplets. We've had a chance to do 3 sets of 3 towers in the past 5-6 years. So I thought that's something new to share with you today. As mentioned, first we were always looking at the BEI and performance, and more recently doing buildings and creating great environments and the making of public realm such as our Saloma Bridge. Okay, One Central, some of you may have seen it before, and it's not very far from here. One of the first buildings of which we it was quite important for us because of its location. And I believe Michael from Arab is here to talk about this. This is a building where, at that time, we were really interested in putting an element that is made in Malaysia, a natural element found here, which is timber. So, in lieu of the, instead of the usual aluminum profiles to create sunshades, we did a sunshade about 30 stories high using Malaysian local timber. I hope none of it came from Indonesia, but it's Malaysian balau. I'm very proud to say that it has never been refurbished, and it's still there. It's been up for almost 20 years since it was installed without ever being refurbished. So I do believe that this material has a lot of potential to be used more extensively in our buildings. As mentioned, we were still very focused on performance, meaning we're not just looking at it, but I always go back in when the building is finished and go to the west-facing facade and look at the 4 o'clock shot, I call it, and make sure that the sunshades that we have put in really work. And that's the picture of our sunshades in the afternoon at 4 o'clock. So this you can probably take a look at it, not so far from here. About the same time, we also worked on several buildings in Putrajaya, of which the Ministry of Natural Resources, I also tried very hard to put in local Malaysian timber. At that time, we didn't have things like, we didn't have our green rating systems in place yet. The Malaysian Green Building Index was formed in 2009, the Singapore Green Mark 2005. So these buildings were done in collaboration with our working engineers at that time. So I wish we could go back actually soon to verify the performance more quantitatively. They were done perhaps more qualitatively and verified by my simple 4 o'clock shot. I'm sure many of you who are architects here would know that besides the building exterior, there's a lot we do to create environments that are low energy, actually, even though at that time we were not guided by as closely by numbers and metrics as today. So very no-nonsense things like creating shaded walkways and creating naturally ventilated atriums were one of the early intuitive ways we did to create buildings that would today be called sustainably designed buildings. For the Ministry of Natural Resources and Environment in Putrajaya, we did do sun shading simulation studies with a very simple software at that time called Suncast Apache. I wonder how many of you know of this very early software to verify the effectiveness of where we placed the sun shading on this building, which was located in quite an open area. At that time, Putrajaya was quite new. There were no tall buildings around it, and the whole place was guided very strictly by urban design guidelines that regulate the height of buildings. So even at that time, we were able to calculate the BEI, the working BEI at that time, at 136 kilowatt hour per meter square per year, which at that time would rank among the lowest 5% in Malaysia and Singapore. The usual other strategies we employed at the podium, where we had the screens and as well light shelves serving as a brise-soleil, as a brise-soleil sunshade to reduce heat gain from the western afternoon sun, as well as to reflect diffuse daylight into the office interiors. We didn't realize all of this, we would encounter a lot of obstacles and all. We tried to create open office plans where all the open offices were by the windows, but we were all held back by regulations such as the government requirements for various grades of officers, like the high-ranking officers all needed to be in enclosed office spaces by the edge. And the open office space were all in the middle of the floor plate with very limited access to light. So these were some of the built-in criteria that would have been an obstacle, that were indeed an obstacle to creating the type of office space that we quite easily do today, with lots of daylight and good working daylight, and yet with a comfortable working environment. As usual, here are our Balau timber screens on the west-facing facade. We took all the corridors out. We minimized the internal air-conditioned corridors and made people walk in the shaded corridors around the building. And this alone would reduce the air conditioning load by 10 to 12%. So the 4 o'clock shot, no green rating, just the 4 o'clock shot. That's how the building looks like. We then, at the time, went on to do Menara Binjai, which is around a 36-story building along Jalan Ampang, not far from the Petronas Twin Towers. And we were here again interested in creating environments behind the facade that were not just the air-conditioned conventional office environment, but the semi-outdoor environment. We created this permeable glass screen that shelters a breezy sky garden that goes up the tower and is accessible every 3 floors in the office tower. That's the sky garden, because we noticed everybody was putting sky gardens in every building, but at the time when you really want to use it, in the late afternoon, it would often be raining and you wouldn't be able to use that sky garden. So this would be a garden that you can use throughout the whole day because it is protected from the rain. You get the breeze, but it's a natural environment. Of course, we tried to make it a planted sky garden, and I think it did well, but in fact it did too well, and the tenants usually complained that there were just too many leaves and too much maintenance. So those are some of the working challenges that we face in creating an environment that are more in tune with the ups and downs of the natural outdoor environment. We also created an outdoor room at the rooftop with these brise soleil on the canopy, the roof canopy, and a bamboo garden. Okay, and more recently, we've been working on this trio of triplets in the KLCC area. Two of them are in the KLCC area. The first one is actually the Star Residence at Jalan Yap Kwan Sing, and the one in the middle is in Brickfields near KL Central, very nearby here also. A set of 3 buildings, which are mainly apartments and some shops below, just opened probably in the last 2 months. And we are also working on another set of 3 towers that due to finish in 2 years' time, called the Oxley Towers, which is a trio of buildings ranging from 30 stories to 79 stories. Okay. But roughly, we wanted to talk about this because they're roughly the same square footage, slightly different land parcels and density, but all amounting to the same almost 1.9 million square foot for each one, with subdivided into about the same 1,004 to 500 small units, and that's the real trend in Kuala Lumpur, where real estate has become so expensive that every unit just have a very limited 4 to 5 meter facade to the exterior. So these presents the similar challenges. Star Residence, a project we actually started almost 20 years prior. It took us that long to complete the building, or for the market actually to develop. And once it did, it's a very vibrant market in KL. Unfortunately, with the pricing so high, always very, very small units are now increasingly being built. The building is located on Jalan Yap Kwan Sing, and we felt it was a very important location. So we spent a lot of time on trying to facilitate walkability in this part of KL, as we know that a lot of people live and work along Jalan Yap Kuan Sing and make their way every day walking along those tiny sidewalks towards the Petronas Towers and the LRT. So we did plan the buildings such that it has a retail with a very, very wide shaded boulevard at the front to create, to encourage people to walk and to walk more comfortably. In terms of the towers, they are oriented to minimize direct east-west orientation, also because of the geometry of the site, so optimizing both. And there are three somewhat repetitive towers, and we tried to activate the facade to break away from the usual rectilinear configuration of the curtain wall and to create movement on the facade, at least visually, so that the multiplicity of these thousands, 1,500 apartments doesn't look so much like it is so intensely dense. So that tries to, in a way, soften the high density and in the same time creating more different environments behind these 1,500 units, meaning if you go into each one, they all don't look alike. They have slightly different configuration of windows and a good mix of course, window and wall. And yet, to be regularized enough to ensure that the whole production is efficient, because it's always a race with time to finish every project. So our client was very keen to create an internal environment that there would be a lot of artwork and paintings, and so we wanted to extend his wish to have that enjoyment and indulging in the world of art and art forms on the facade itself. And we developed what we call a Mondrian motif on the facade to activate the facade. And it's not just straight lines up and down the building. It creates a very strong dynamic brush stroke over the facade. And at night, the lighting on it activates it such that it simulates what we call the meteor shower. So it happened that the buildings were also called the star residence. So we thought that was quite appropriate and gives an easy understanding of the thematic concept of the building. This is what it looks like. And by having this motif across, it sort of breaks up, doesn't make it look like all these little cubby holes in the towers and all somewhat looking at each other, but it sort of breaks down the multiplicity of units at this place. And the interior environment, here's a typical unit. You can see you have a Mondrianus pattern from which you enjoy the views of Kuala Lumpur and the river, which are not very far. And of course, many of the views enjoy beautiful views of Petronas Towers and the other towers around the park. At this stage, maybe I'll get Michael to share. He had the difficult task of working out and regularizing all of these panels on the tower.
Hi. So the units are, the facade actually designed in a way that it actually have a different, 4 different modules of interior experience. So as you can see here, it's actually designed in a way that it repeats itself after the 4 floors. And even inside the unit, we are actually able to experience the Mondrian pattern from inside, and as if that you are in the same neighborhood with the other neighbor. And because of that pattern, actually it allows for the lights to come into the rooms and plays with the shadow that is actually different and played throughout the day. So this is a simple diagram showing how actually the 4 modules are being stacked. But of course, this is just a simple diagram. It actually consists of the whole floor. And so it's actually able to create an environment where you have, when you buy a unit, you actually don't just buy the window, but you get to buy a window with the full height, wall-to-wall Mondrian painting with KLCC, City and KL Twin Towers as your backdrop. So to keep it simple, so that is how actually we stack the 4 different module and experience from the inside. And that is just for the inside, while for the external, because we need to create that continuity throughout the towers, we actually using the 4 sets of the 4 modules, which is 16 floors, and we repeat it 3 times throughout the towers. So that is, this is just a simple diagram showing that how we are able to not just design the facade in the Mondrian pattern, but it allows us to give some flexibility to height and put it all the operable window, which is also part of the requirement on all of our residential and residential towers. So as you can see from the photograph on the left, this is just one set of unit where you stay on that floor. This is the view that you'll get. But as you go to the next room or go to the next unit, you will have a different configuration of the window. And we also carefully design the window in a way that it doesn't create so much blockage to the unit, because as we all know that the views to the city, to KLCC is actually always the prime consideration, especially to the developer and to the value of the unit. So with this, we actually try to keep within 75% of window to wall ratio. So this is the view that is from the podium. As you can see that because we are using different materials, colors and configurations, it actually consists of the tinted glass and 4 different color patterns that actually how it can create the effects of a different look throughout the time. So go into the technical a bit. For all the towers that is beyond 30 story, we actually encourage the developer and the client to go for curtain wall system. That's because it actually helps us in terms of the safety, construction speed, and also the warranty in the future. We will explain that later on throughout the end of the slides. But this is just one of the steps that we did. It has to be done because all of the unitized curtain wall panel needs to be tested actually before it go for the full fabrication. And this is where the architect and the consultant will be able to check and test in terms of the design and also the and then the structurability of the facade. So for Star Residence, we actually have about 1 million square feet of facade area. And for this, we are dividing into 2 different facade contractors, and each of them have around 50-50 of facade construction costs. And this actually allow for...
Sorry, let me say, to 2 different local Malaysian contractors.
Yes, to 2 different local contractors. And this is actually to allow us and the developer to manage the risk and to spread the risk. And at the same time, both of the contractors can work at the same time to complete the project faster. So,
of course, it creates more work for the architect because we have to check 2 different sets of shop drawings. And it also it seems, some of it is partly the limitations of many of the capability of the local contractors, the local fabricators. It is a good way to split it up so that the work can happen simultaneously. And we were more committed to doing it locally than to have everything shipped in from elsewhere, and then having to and that's very difficult when there are defects and inconsistencies to resolve. So having the contractor right here, it's much faster from the testing at the VMU and going through the shop drawings. So we felt it was good, and it turned out to be quite necessary, I think, not just an option to spread it out. Most of the good contractors are not exactly so large because there are not so many of these large 1 million square foot of building facade in the market. The second of the trio of towers is Oxley. It's actually not quite finished construction, probably another year and a half or two. It's at KLCC. We were very proud to have been selected for this project from a competition. We have a Singapore client. Our office actually was on just opposite the Petronas Towers for over 20 years. So we had been watching and waiting for an opportunity to do a building in this the crown jewel of KL, really, the KLCC area. And we were very grateful to have this chance to do this a triplet of towers ranging from a 30-story office building and 2 mixed development towers, each with a hotel and also service apartments. Both the towers have, all the towers have views of the park, maybe not direct, but fairly close views of the park. That's the current, one of the recent photos. It's hopefully will be completed in 2 years. It also has bridges. It has, in fact, 2 bridges, a lower bridge and an upper bridge that have successfully been lifted about 3 months ago. We were able to lift and complete the lifting of the lower bridge in place, and we were very glad to work with a very excellent Malaysian contractor on doing the bridges. In terms of the architectural design, again, we continue our aspiration to embed our buildings with some elements of the local tradition and bringing in elements of our cultural tradition. And in this one, we worked with using the diagonal lines of many fabrics, textiles in Malaysia, whether woven, they will, because of the nature of the weft and the weave, there are also very many intricate patterns with diagonal patterns, which we tried to express on these 2 towers, or on the 3 towers, as well as on the screens for the car park podium. As you know, KL has quite a requirement for car parking. So by the time you build a building like that, you will need a total of about 10 stories of car park. Half are below ground and the other half above ground. And a building like this, like Oxley, is also enabled because Kuala Lumpur, at that time when we were doing the planning approval, happened to wisely reduce the amount of car park requirements for city centre buildings that enabled the building to be built up to the volume we have, 1.8 million, 1.3 million square foot. And the facade is modularized. And because we have the diagonal, we sort of created for ourselves a bit of a problem because we have diagonal thin elements crossing the windows. So on this project also, we have quite a lot of facade that are actually screens because we centralized and created a nest for the aircon condenser units so that they are not individually in every unit, causing it to be usually poorly maintained over time. So this neatly nest them in a central area that are on the sides of the building with no views. So the AC farms actually present another facade that we had to deal with, which are mainly mesh that also carry the same motifs as the glazed facade. Okay, I think this one is due diligence that we have to do for every building. We do, including, of course, to test for comfort levels at the high-level open area. We have a swimming pool on the 79th floor, so we needed to also design the crown of the building such that there is some openings for the wind to blow through to reduce the wind load on the glazed walls. Again, we are coming back to where we started with Menara Binjai I showed earlier, where we have these perforated walls to create and to manage the wind conditions to create a more usable and comfortable environment on these terraces, outdoor, semi-outdoor, outdoor terraces. In this case, it's a 79th floor swimming pool deck. Okay, this is the complicated part that I always relied on Michael to help, and so he should talk about this. It's very well and easy to design the facade, but as my first boss at KPF used to tell me, and whenever we showed him what we're doing, the first thing he said is, how do you clean the building? And I never forgot that.
Yeah, so for Oxley, we actually have not just the three typical BMU gondola that will put it on the rooftop. As you can see, aside from the rooftop gondola that will serve the maintenance access for the facades on the tower, we actually have another two sets of monorail that will be able to help to maintain the facade of the two bridges. And because of the bridges are overlapping and some of the tower facades are actually sitting below the bridge, so that is why we actually need to have another set where we use monorail track under the bridges. So that actually will allow for the future facade maintenance access. And it's a lot of things that we learn from here, that we not just deal with the access, but it also deals with the movement of the bridges and the location of the monorail, where it is going to be start. And of course, for the podium level, we propose and to have just a normal skylift system. And this is actually the mock-up that maybe you want to explain on the local contractors.
Yeah, Michael and I make many of these trips to the middle of some rubber estate where most of these testing labs would be. But I always really enjoy it. And for Oxley, I discovered that the contractor, facade contractor, was actually the same contractor who did the cladding for the Petronas Twin Towers. We always thought that everything was done by Caesar Pelli and team, but I'm very, very proud to have worked with Mr. Chia Chati of Laksun. So very proud that he was the man who did the entire cladding for the two Petronas Towers. So we were really delighted to have a chance to work with him on our much smaller building. Nevertheless, he is still sort of a family outfit. He and his son, who is still running and still on the floor in the factory. In fact, he even has the original mock-up of the stainless steel linen finish cladding, which are at the front of the Petronas Towers. I'm sure you will see it each time you enter. And even a small section of the teardrop shape, the Petronas logo, teardrop shaped sunshades that you find on wrapping around both the towers. So it's really such a delight to work with people who have done such a complex building. Imagine the Petronas Tower is about 88 stories, and there are two of them, and he did both of them. That's equivalent of about 180 stories. That's taller than the Burj Khalifa. While I mentioned earlier that they may be small, but the capacity to have delivered that is great, and he's helping us right now on part of the cladding for the Oxley Towers. There's Mr. Chati there, right in front of that mock-up, on just outside his factory. He just have it outside his factory, and they say, "Oh my God, this one is like a relic to be kept." So, and he's, so it's amazing working with them. They're very, very detailed, and we do mock-ups, some of them even sort of handmade mock-ups to resolve all the angles. That's the thing when you have all these diagonal motifs, you have a lot of corners, and when you have the chamfered volumes, skyline, profiling at the top of the buildings, we also end up creating a lot of very difficult corners that we have to resolve individually. I'm so delighted and proud that we have the fabricators here in Malaysia who are able to support the execution of what I consider for us quite complex geometries on the building facade.
Okay, so similar to Star Residence, Oxley actually have over 1.1 million square feet of facades. And again, we are breaking the works into two different local facade contractors that is equally distributed in terms of the area and construction costs. So we move on to Central Suites. This is actually a project that was recently completed and it consists of 3 blocks that doesn't use curtain wall. It actually uses a window wall system where it is about 43 story of towers. And we actually design in a way that because of the massing of the block that is very huge, it doesn't stop us from the design of the tower where we actually introduce the lines, the angular lines to the building facade to create the slimmer looks into the overall building massings. This is actually inspired by the turmeric concept where it is actually has a very strong tie to the local culture in brick fields. So with the interplay of these angles, patterns, at the same time we are able to introduce a series of sky garden and pocket gardens that actually will help to create some small little community within the towers itself. So this is the views of the sky garden and pocket gardens that actually spread it through around the 3 blocks. And each of the sky and pocket garden actually have a distinct view towards the city skyline. So now, next, so what is the advantage and disadvantage between the unitized curtain wall and window wall system? So this is just some due diligence that we did for one of the earlier projects for over 60 story. And on the left is actually a detailed calculation on the curtain wall, if we are to use curtain wall, and on the right is if we are to use a window wall system. And what we found out is actually for this type of building, the conventional window, the window wall system actually will cost around 7% of the total construction cost, while for unitized curtain wall will cost around 9 to 10%. And that is actually about 2 to 3% different. But because there are slight difference in terms of the facade, and most of the clients or other consultant will actually try not to use curtain wall because it actually makes the client need to pay upfront, but it actually helps and it's actually worth it to spend that extra 3% to change from the window wall to curtain wall system. We'll explain that in the next slide later. So these are the summary of the previous projects that we have done. As you can see, generally for projects that if we are to use curtain wall system, we should allow for at least 8 to 9% of the total construction cost. And if we are going for a green rating, maybe we will have to bucket up to around at least 10% because that will have a different specs of the curtain walls design itself. So now, in terms of the construction and installation space of the facade, as you can see on the left, the blue one is actually a curtain wall system, and the red one is the window wall system. And that split itself actually has proven that with the 60 story of building, the facade works actually can able to complete within 9 months, comparing to the window wall system where it actually need 2 years. So the question is that 3% of extra upfront to pay is actually will be worth it, because that will expedite and shorter the completion period between the stage 2C and stage 2E. And that will help on the payment and cash flow for the developers. Of course, that will have a less coordination works at site that usually causes delay, and single point responsibility where curtain wall, all the facade will be under one contractor responsibility, and of course the lower risk of rainwater leakage.
I think this is the last one. All just finished, and we don't have such great photos, but this is also another one where we focus a lot on what you experience behind the building facade. This is a hotel and service apartment development, and for each service apartment, hotel, there is, for each of the hotel rooms, there is actually its own private swimming pool behind the facade. So that was another new challenge we had to deal with, but of course we made it a challenge, a bigger challenge for ourselves by wanting to be able to see the swimming pool, to see the water and its reflections on the facade. So but we don't have the best photos. Hopefully the next time we'll get photos. It's sort of rainy season. But you can see there are swimming pools. You can see they've all been filled. They're just starting to open the hotel for bookings. So we look forward to when it's really fully used and the lights will be on and every swimming pool will be seen and visible on that facade. So that's how it is behind there. And it also has a viewing deck where you saw that great view. And last, I just have 2 minutes to cover this. This is a project that we had done, we completed during COVID actually. In fact, our architect Azril is here as well in the room. But we had to show it because this was again a very challenging piece of construction with multiple pieces. We feel very proud of it because we helped to encourage the creation of this bridge at this location that will connect a very undeveloped part of the city of it's Kampung Baru with Kuala Lumpur city centre, the very, very developed international business hub that it is. It was totally 2 worlds apart, and the bridge really helps to bring together these 2 worlds. And every morning there are lots of people crossing over. So the joy of seeing that, that it's so active, because it provided a needed connection, a pedestrian connection between 2 very vibrant and important part of the cities, of course, having the bridge also brought a lot of people who didn't have to. It has become such an iconic place that people who are not really wanting to cross from the other gather there every night just to enjoy. And we're the whole environment. And we were again very lucky to have worked with a very fine building contractor. Unfortunately, he's returned to Australia. It was really a joy working with him. We actually worked through all the mock-ups. We're starting from paper cardboard mock-ups of the complicated parts because of the curved geometry. There is a lot of effort was made to again systemize it into one single size and one single shape of the cladding. So I think that should wrap up our presentation. It's a very active space at night. It's very full. People will just come to this place to enjoy the views of KLCC. Okay, I think this one, if you happen to be in Brickfields and taking a walk there, there is a very small building that we're very proud of because unlike all the people who do all the Chanel and Louis Vuitton shop houses, we never get to use a low iron glass. And we did a commemorative pavilion to commemorate the destruction of a very old neighborhood in Kuala Lumpur, where we've salvaged part of the old relics from the old 100-year settlements to excellent. Okay, all right, thanks. Sorry, just had to show this, just in case you can have a chance to walk on it. Okay. Thank you.
Thank you, Lillian and Michael, for your wonderful presentations. I wish I will have more time to listen more to you with this fascinating facade design that you have done for many projects in KL. And we would like to welcome Paulina from Yotun, or commonly known as Jotun in Malaysia, to share with us the coating and painting contributions on the green buildings. Welcome, Paulina.
Thank you. Good morning, ladies and gentlemen. I'm very pleased to be here all the way from Norway to present to you today. And my name is Paulina Marciniak. I am Global Marketing Manager for Jotun, and I specifically work with powder coatings. And every day, together with my colleagues from R&D department, from Research and Development department, with our color lab experts, we push the industry towards more sustainable future for the next generations. And we are doing this by developing products and solutions for green buildings. And this is the presentation which I'm gonna give today to you. I'm gonna tell you how coatings and our solutions can contribute to more sustainable, long-lasting and beautiful architecture. And I don't have the clicker. Okay. But why are we even talking about sustainable architecture? Why this topic is so important? Well, the several studies, they show that building and construction industry generates over 40% of annual global emissions. We must act together because the consequences of the climate change are already affecting us. Droughts, floods, fires, and more extreme weather conditions. This is all the signs of the climate changes, and we cannot ignore it. The United Nations Intergovernmental Panel on Climate Change has estimated that we need to cut emissions by 45% overall by 2030. While the Paris Agreement set up the target on 55%. More than ever before, has governments, nations, and businesses decided to take an action, and they have aligned on the global targets. Consequently, the demand for sustainable solutions is increasing. And we have to admit that green buildings is more than a trend in architecture. It is a demand to create green buildings and contribute to the certification, to be competitive and to stay compliant. But before I will proceed further with the topic, I would like to tell you a little bit more about who we are and what we do. So Jotun, for almost a century, is protecting, as on a mission to protect and to beautify buildings all around the world, and different types of assets. But it all started in 1926. In 1926, in Sandefjord, in a small town in Norway, where we were at the beginning producing and selling paints to protect and beautify, but mostly to protect vessels, ice-going vessels traveling to the Northern Ocean. And today, with almost 100 years of experience, we are protecting and beautifying assets in a variety of industries, such as energy, shipping, and infrastructure. We are more than 10,000 employees in more than 100 countries, with innovation hubs all across the country, all across the world, to be close to our markets, to get better understanding of the local market needs. But our headquarters is still in Sandefjord in Norway. And this is not a computer-generated picture. It's an actual photo of the lighthouse in the west coast of Norway, where the waves can be up to 60 meters tall. And at the same time, the temperature in the winter drops to -20. So you can just imagine these extreme weather conditions. And the long-lasting protection requires solutions that can withstand this type of weather, any type of weather, all year round. We also believe that long-lasting protection supports more efficient and safer environments. It reduces costs, it reduces the need for maintenance, repairs, and at the same time it reduces emissions, which is the major contribution to reach sustainability goals. And I will show you just a couple of examples of what do we understand as long-lasting protection. This is the Ekofisk oil field on the North Sea. And after more than 30 years, there is no corrosion, which is a third-party verified. This is what we call long-lasting protection for safer environments, for more sustainable and more efficient constructions. And this is a very nice example of long-lasting protection and beautification. Burj Al Arab, iconic hotel and a very well-known building in Dubai, was protected by Jotun Super Durable. It's our powder coating, and after 27 years, you can see that it still looks as great as intended. And even better example, it is Atlantis Hotel. Hotel built on the man-made island in a shape of palm, a very fancy place, in Dubai as well, where you can see at the picture that after, it's almost 70 years now, not only no repairs or touch-ups were required, but it's almost basically not possible to say which picture is showing a master panel that we kept from the construction period and which is the recent photo of a door profile. So long-lasting is crucial for sustainable architecture, but beauty matters. It is an important element of design. We want to give the possibility to architects and designers to express their visions, to bring their visions into life. Because creating visually appealing, visually interesting constructions enhance the overall experience of the space. And it also contributes to the overall feeling of well-being of those who interact with those spaces. That is why we create the color collections. Color collections inspired by nature, inspired by life moments. And that are not only beautiful, but they also are part of our green building solutions. I will tell you something more about green building solutions in a moment. Thanks to this, they can contribute to achieving points in the green building rating systems and standards. So anodized look, the deepest matte and high shine metallics. This is all possible with powder coatings. Did you know that paints and coatings represent less than 2% of a project budget? While at the same time, it can contribute up to 20% of green building rating points, such as LEED. If you didn't know that, that's all right, because we have our green building solutions team, and they can help you to navigate in all these product solutions and documentation that is necessary to achieve green building points. Our green building solutions, I mentioned before, is built on 4 elements: products, digital guide of the green buildings, extensive documentation, and green building specification guide. All of this to help you to specify green architecture. But we understand that it might be still a little bit difficult. Even though we have more than 400 environmental product declarations across all the product categories to make it easy to pick up the right product. So we are a single source solution provider, but since it's still maybe confusing, our team of experts is there to help you through the whole project from start to completion. And by start, I'm meaning providing samples, then selecting documentation, collecting documentation, then deciding in which categories you want to apply for green building points, and finally, quoting. And I said before, we want to empower architects and designers to make them able to bring their vision to life, to make them able to be creative and without any limitations, but at the same time, bringing this vision to life, actually quoting building elements. It may be difficult, but we have more than 500 Jotun approved applicators across the world who are trained and who are there to make sure that you always get the excellent result of the quoting. And our best-in-class technical support is also there to provide their knowledge and their experience and to get the most efficient and application and the best result of quoting. And also to solve any type of troubles and answer your questions at the spot. They are there, that are the local people available for you. So just to sum up what I said till now, paints and coatings can contribute to sustainability goals by providing long-lasting beautification. And I believe that with VOC-free products, with TGLC-free products, with energy-saving and efficiency-improving solutions, specifying green buildings will be easier. But with our green building solutions and more than 400 EPDs, environmental product declarations, for the products from all categories, it will be even easier to achieve green building ratings, green building points in international and local rating systems and standards. And finally, there is our support team who is there to help you through all the process, to navigate and to choose the right products, collect right documentation, and also support you in the quoting process. So through the whole the project, and we say even beyond. Because the future of construction relies on turning visionary ideas into reliable, sustainable, and beautiful architecture. And we are proud to be chosen and to protect 13 of the 20 tallest buildings all around the world. And with our products and coatings and paints, we protect and beautify iconic buildings everywhere, all around. We are here to empower your visions and to support you to turn your visionary ideas into reliable, sustainable, beautiful architecture whenever you need us. And yes, green buildings solutions, this is part of our mission. With this, I would like to say thank you very much.
Thank you, Paulina, for your wonderful product sharing. Let us welcome Michael from our group to share with us the balancing the aesthetic and functionality in facade. Before Michael get on the stage, let me remind that those are accumulating the LAMP CBD point. please go send your details to the registration counter so that you can collect the points by end of the event. Thank you. Welcome, Michael.
Thank you. Thank you. Hi, morning everyone. I'm glad I'm not talking about visual mockups, performance mockups, and construction costs because Lillian and the team and Michael already covered all of that. So I've got a different set of slides. Hopefully it will be quite interesting today. In the interest of time, I'll just breeze past some of this. You all know Arab multinational firm. We've got a 250 people strength team in Singapore, in Malaysia, and we've got a full suite of engineering disciplines, all based locally here in Malaysia. I won't talk too much about this. 94 offices, 18,000, move up and down depending on the economy. Facade, we've got about 300 people globally, of course. But in Singapore, we've got about 30 people. In Malaysia, headed by Sean, we've got about 10 people. Right? So these are the network of facade leads in Arab for Southeast Asia. There's another person coming up in Indonesia, but we can't show his face yet, not yet. But these are the guys essentially you'll be dealing with in Arab for facade engineering. Okay, so today I actually talk about digitalization. I mean the topic is it's quite long, right? Balancing aesthetic and functionality in facade design and Arab's approach. But by that, simplistically speaking, we are going into digitalization. We are selling a lot of digital systems, digital way of doing things, right? It's one thing to sell, and bring some of this offering to the wider engineering work that we do. But we actually do a lot of things internally, right, to make our processes more efficient. Right? And these are some of the things that you don't see. So perhaps today I'll just talk a bit about this and give you a sneak peek of some of these tools that we made mainly for ourselves, to make ourselves more efficient and to help our work become more efficient so that the mundane stuff can be done by computer, or programming or software, while the guys here can actually spend their time doing more value-added stuff. Okay, so I'm talking about process automation in facade, and the key word is data, right? We talk about AI, we talk about, and it's a big word. Data and AI is something that has been widely talked about, right? We know the tech and we know how big they are. In Malaysia, AWS, the data, big tech firms are building tons of data centers, and it's really to house one thing, data. But how we use data, how do we actually process them, that is something totally different, right? Rubbish in, rubbish out, obviously. So this is kind of like the triangle that we use in Arab. We essentially said, the data below is what we collect, right? And we kind of grow and grow, but essentially it goes up the hierarchy, of information, knowledge, and the last part is wisdom, right? And how do we actually use data to help us, rather than anything else. Too much data, don't know how to process, becomes an issue. We all know that. Okay, so I'd like to talk about 4 different products, not products, I suppose, software, methodology, whichever way you call it, that we developed in Arab to actually help our process, expedite our work, make ourselves more efficient. Like it or not, we say, we always want to increase productivity, especially coming from Singapore. Increase productivity, improve efficiency. That's like the mantra that our government used to say. But unfortunately, it's not one of the things that's synonymous with Arab. Arab like to sometimes go round and round and round and round until we get to a point, and that's what we call sometimes optioneering. All right, so some of this software here hopefully do help us do that in the quickest way possible, without using the human brain power too much. So So facade canvas, number 2, Arab solar, generative design, and inspection and reporting. So different aspects of facade work. Okay, so the first one I talk about, facade canvas, is essentially, sometimes we, especially with architects, we do a lot of optioneering. I want this option 1, option 2. 6 meter floor to floor, then 5.5 meter, 1.5 meter width, and then 1.8 meter width. And there's just endless permutation. And the usual process last time we used to do a sketch, we do a CAD, whichever way it is, goes 3-4 options to the architect, comes back, and then the architect says, no, this one cannot, this one not feasible, let's do it this way, try this. So we've developed a script in-house using Rhino Grasshopper, and these are not new software, these are just kind of us making use and customizing the software. And you look at this software, what we have done in one video, we essentially can, curtain wall design, we can shift the modulation, we can shift the height, we can literally shift everything quite quickly, including the angle. Right? So the idea is to go back very quickly with the architect. Sometimes we actually sit in the room, in the workshop with the architects, and I tell you, oh, is this what you want? This is not what you want, let's change this. And everything is done virtually. So in the end, there's a lot of less to and froing. Virtual, everything done virtually with a screen. I've got a young or youngish guy sitting beside me who knows how to operate the computer, and that's all you need, right? Very quickly. But one of the things for this, we can also immediately look at things like deflection, structural engineering, how deep are the mullions. All of these are integrated. And if you kind of think of it, it's only data. There's no end to what we can do. We can put in solar analysis. We can put in thermal comfort analysis. We can put in all sorts of engineering analysis all within one software. It's just whether, what you can put in and how you want to do it. So we custom-made some of these things for project, but essentially it's something that we are already doing. Then it translates into 3D model, right? We used to do 2D, and frankly 2D, we find that sometimes in today's context, people don't read 2D drawings anymore. You look at section, you look at elevation, alamak, they don't gel lah. Cannot imagine. So a lot of times you tell perhaps a younger generation architect, it says, let's change this on plan, and then let's change this on elevation. But he cannot imagine. So the standard question we always hear is, let me go back to the model. I'll need to model it first. And that creates another, I suppose, level of complexity and time. So what we then do, the software is then able to then translate into quite accurate 3D models like what you've seen here. So we are moving into a lot of 3D, and of course we can also do 2D like that, which are, literally just a cut section of the model. Studying, of course, this is just another one where we look at curved surfaces. This one, if it's a flat glass, it's very easy. But when you start looking at it, when you start tilting it, it becomes a double curve. Sometimes it's very hard to imagine how would that piece of glass actually look like and shape, until you actually draw it out. But with, in a 3D angle, a 3D environment, it's actually quite easy, very quickly. Arab solar is what I talked about, some of these things that we put, the environmental, obviously, we want to do as much as possible. We look at solar analysis, we look at thermal analysis, shadow analysis, and all that actually defines, as Lillian said earlier, your sun shading. How deep is the sun shading? Do you need it for all elevation? Is it efficient across all elevations? Probably not. Some areas better, you need it bigger, some areas not. So all of this must be a scientific way of doing it. So again, we develop a software and we use it in Google HQ. I think it's just recently completed. And essentially, it's a challenging site, right? Sometimes you can't do so much with the massing. Of course, you say east and west, it's always going to be more solar exposure. But unfortunately, my site is so long, so we have no choice. And then, of course, in London, we have very high efficiency targets. So when we start building around the model and we look at the facade and we kind of compare, when when are the times that we need to do the shades down, and the areas where, the time when you actually can do, amount of time where the shades needs to be up. So all of this can be looked in a very smart pictorial way, and you start adjusting G values, we start adjusting G value of the shades. All of this integrated, and it's very visual, right? You can see it. So one of the other things that we start doing for this, because of the east and west, we actually looked at shingling, making the facade self-shading. So when you shingle like that, then obviously it immediately becomes a bit self-shading. But then, is it two-fold? Is it three-fold? Again, when we put it into a software, we can see how many splits that we want to do. It's just a really nice functional way, a technical way, to tell someone this is perhaps the best fold options for your project. A scientific way of doing it instead of, sometimes just kind of, because it's visual, or because it's something that is easier to build, for example. All of this can then look at some of these aspects from a thermal performance point of view. It's been built already, almost kind of, I think it's almost complete, right? Except for the TOP stage. So at the moment, this is how it's kind of look like. Generative design is another one that we've started to do. All these talks about AI and all that. We've not actually gone that yet. Our design, our software is not meant to do that. But essentially what we are doing here is, if you start thinking about kind of a blank sheet, right? How should your building look like? What should the shape of your building look like? What is the general massing? Now we kind of then say, we can probably put some criteria to it and then run it and then say, what is the best option massing that you have for this that meets certain criteria? So like in this case, we've got 4 different criteria. If you do your criteria too big, no good, because basically it may not converge. You want everything, but actually in the end cannot be done. If you make it too stringent, you also get another problem. So the idea of that is that, what is the range that you're willing to accept? Like in this case, it's a controlled GFA, minimize solar exposure, minimize daylight. And then peculiar to this site, we actually want a maximum view to a certain area. So then we put into these are the 4 different criteria that we want. We put it into the generative design software. We run it over a day or 2, depending on the complexity. And it will tell you what you get. Essentially, go back to this, the massing that most closely aligns with some of these 4 criteria. Then you can start your development. But of course, some plots, some projects, or may not even, you actually have no choice to play with the plot so much, so you have no choice. But in this case, we were able to. The other thing that we looked at nowadays a lot is the PV, right? For our temperate climate, Malaysia and Singapore, we are just kind of, the sun is always above us, above the equator, because we are in the equator, right? So east and west is no-brainer. That's the areas where it's most subject to higher solar exposure. But at the end of it, how much of that? So we know putting solar panels flat, on the roof, on flat ground is the most efficient. That one is no-brainer, but it's not enough. Right? We're starting to put BIPV on facade. But BIPV on facade, you got 4 elevations. Right? East and west is probably the highest solar exposure. North and south, maybe, but what's the scientific way of doing it? Okay, we want to maximize, we want to leverage. So when we put it into a model, we start looking at the depth of the BIPV, the shape, the height, the width, and then we kind of run it through that process, and we can see which elevation give you the highest solar exposure. Of course, east and west, it's kind of no-brainer, but at least it gives you a scientific way of saying, hey, this is the area that is highest, and if we delineate it properly, we can even tell you the highest portion, the highest 1/3 floors are the areas that are highest solar exposure. Let's put it there, if I don't have money to put everywhere. Because of this net zero, because of decarbonization, this is something that we we have to do, right? What are the possible areas of renewable energy in our region? I would say it's only solar, right? That's why we are going all out to do this. So in the end, it can give you, once you do your sums, it gives you quite an accurate number, how much of energy you can generate based on a certain number of efficiency, and of course, then you generate your ROI. Once you have the ROI, then obviously you either accept or not. It's something that you pay or don't. Rationalize it. Another one that we do a lot is, of course, rationalizing of panels. Very often we get visuals like that, especially in the very early concept stage. So how do we actually build? And this is a museum project, so I'll just go through some of these things very quickly. It's like a blank sheet, right? And then how do we panelize it? So we've got panel weight, wastage, number of unique panels, fabrication. All these are construction criteria. But once we start running options into it and put it into software, we can then see, hey, is this options? These are kind of like the 3 squarish options. So when I do a square panels, obviously some of you will know, less wastage. If you do a square panel, it's longer, it's flatter. You have actually less panel as a whole. But when you start doing it in a large canvas like that, the size can be potentially quite huge, right? And if you've got a different curvature, for example, the triangle may not be, or the rectangle shape may not be so nice. So eventually this went back as a first option. They didn't really like it. And then we tried a series of triangulated options. Obviously, when you say rectangular and triangular panel, suddenly the wastage will almost double. You got a square panel, you cut half. No matter how you do it, it's always going to be higher wastage. But it's nicer, it's prettier, and for a triangle pyramid shape like that, obviously the triangulation is the way to go. So some of this, from beginning until the end, the optioneering, it just needs to go through a process, and the quicker we go through this process, the more money we save, the more time we save, the more efficient we are. So this was eventually the final product. The total number of panels, 867, and we've only got 6 unique panels. So when you kind of look at it, okay, not too bad. Yeah. The more unique panels you have, the more money you spend, simplistically speaking. This is for the tower. I won't talk too much about that. This is a project in Malaysia somewhere. I won't divulge the location, but again, this is cloud-like structure at the top. One big blob. How do you rationalize it? And sometimes the devil is in the detail, right? You always say, leave it to a contractor, later they will sort it out. But actually, if you don't start doing some of these rationalization or modulation studies from the beginning, you will not be able to get what you want downstream. That is 100% sure. So now when I say devil is in the detail, it means that at concept, at this stage, we've got to make sure we put in as much details as we can and we spec it right so that downstream, the contractor can price and then, of course, can build the right thing. So in this, again, is a blank canvas. And this one with another added level of complexity. It has curvature. So it's all going to go triangulated, right? Because triangulation, flat panels, is probably the best way to deal with a slightly curved structure like that. But what type of curvature? What type of square panels? What kind of modulation? Again, when you start looking at it, optioneering, went through a few rounds, and sometimes the process can only be done using automation. This is kind of like the visuals automation that we do, and essentially what is done is at every the bottom square is actually all the different sizes superimposed on each other. So you can see, the idea is to reduce the number of iterations and make it, of course, the ideal one is all perfect square, but it's not going to happen like that. So when we put it into software and with a script, we start to rationalize, and some of these areas where it's, like that, for example, it can be smoothened. So when we start adjusting the curvature bit by bit, then the idea is really to get down the number of unique panels to as little as possible. This one we still can't get away too much, but the total number of panels are still quite a bit. We can't do more than that. We ended up with whatever number it is. It will still be rationalized, but the main idea of this is we go through this process to rationalize the curvature. Right? I think in today's context, unique panels, as long as they are flat, it's still not so bad. It's a problem with trying to match the unique panels to that location. That's the problem. Right? But if the construction methodology is fine, it should be all right. I won't talk a bit about this. These are just structure. Eventually, a resolved geometry, something like that, and then we can document it. So when you document something like that so clearly, the contractor can follow. It's also for them. Right? Otherwise, you have one big block, everybody interprets it differently. So it becomes an issue for them also. Right? And then you come up with issues with variation, VO, and all that, right? Downstream. Won't talk too much about this. I'm running out of time. Okay, so the last one, inspection and reporting. So one of the things that we do, existing buildings, right? Defect, how do we actually, record some of this inspection? The previous time, I don't know, some of you will probably have realized this before. We've actually gone down with elevation and plan, and we mark when we see. When we start doing inspection. So a picture on the left, we actually mark it down on the plan itself. A lot of us suffered this pain. I imagine if you have to do 100% inspection. It's just too painful. So on the right, we've started to build a 3D model, and it's actually a BIM model, but simplified BIM model that identifies every one of these areas. And the idea is to record whatever defects that we find in the model, and everything using this software. So then you keep a record, right? You can always know and go back and identify some of these areas. And some of these buildings you do 2-3 times, right? So it's not only in record today, but it's a record 5 years down, it's a record 10 years down the road, and it's always kept on record. Anything on paper is gone tomorrow, right? You can't even do anything, and then you scan it, and it's even worse. It's just mountains of sheets, which we never use. Drone is something that we do. Again, it's one of those processes that we say when we do a model. Nowadays we use drone to actually take photographs, but that drone will go into a software and a defect analysis strategy before it gets mapped out on the model. So it's the same thing, essentially, but a clever way of using drone instead of using human doing that. We do a lot of this. I'll just quickly run through some of these inspections, as you can see. And we have 2 registers in-house to actually register, to keep all our tools, right? Okay, so very quickly, I think this is just a snapshot of what we do. And it's behind the scenes. You don't really see a lot of these things, but I divulge a bit today. So sometimes you see some of the things that you say, hey, how come it's so fast? You can come back with all these options. It's just because we have done a lot of the homework behind to actually get it to this point. And that's the only way to go, because facade is getting more complicated, engineering is getting more complicated, the aesthetics, the architecture is getting more and more complicated. And without some of these tools, we will not be able to realize some of this architecture that we are seeing now at all. Okay? So with that, I think, thank you very much. I'm still around, so if you have any questions, please look for me outside, no problem.
Thank you, Michael.
Right.
Thank you so much. We have one more speaker before our first break. Let's welcome Matthew from Voltec by Vector Voltec to give us a presentation about the ETFE product. Welcome, Matthew.
Hi, good morning. So you've probably all heard of ETFE. Let's jump straight into the technology. What is ETFE? So ETFE is an acronym, ethylene tetrafluoroethylene. The important thing to remember here is that ETFE is not a plastic. It's a fluoropolymer with a key ingredient being a natural element. It does not have problems with fire, UV, sustainability, or longevity. ETFE has been around since the 1940s, developed by DuPont, and it was our founders over 40 years ago that brought ETFE into the construction world, and we've been the leader in design, supply, and install of ETFE ever since. I want to really start with the technicals first before we get into the project. So what's the principle of ETFE? Typically, 2 layers of ETFE, welded at the perimeters, fixed into an aluminium frame, inflated with air. And it's that air that gives shape, strength, high thermal performance, high light transmission, and very lightweight. So if you were looking at the underside of one of our roofs or facades, typically you would just think this is giant panes of glass. You might see a small inflation pipe in the corner, but if we've done our job, that's well hidden. And from above, you can see the ETFE aluminium perimeter frames fixes onto the steel cleats that fix onto the steel structure. Now, just for the facade people, this is a cross-section of our perimeter frames. Yes, it's lightweight, but it's watertight, airtight, allows for large thermal movement, large structural movement, plus secondary drainage channels. Is ETFE strong? It's incredibly light. Our systems are typically 95% less weight than a curtain wall system. This is a very old video from over almost 25 years ago on Tomorrow's World, showing how the principle of load sharing works. ETFE pressure, and it gets distributed across the ETFE cushion. We also have single layer systems where the air which forms the cushion is essentially replaced with cables to give a flat look. So some of our most famous projects: Beijing Water Cube, constructed for the 2008 Summer Olympics. This is currently the largest ETFE clad building in the world, 100,000 square meters of ETFE. It has 4,000 ETFE cushions, because the ETFE is not just the building roof, the building facade, it's the building ceiling and the building finishes. Because ETFE is completely unaffected by the chlorine given off by the pools that's highly corrosive. This is currently the largest project ongoing in the world. Of course, it's Saudi Arabia. It's the King Abdul's Gardens. This is 120,000 square meters of ETFE. And these dots you see at the bottom of the picture, they're excavators. We don't go around on bicycles. We literally go around on motorbikes. The reason they're using ETFE: lowest carbon footprint, sustainable, recyclable, and can deal with the sandstorms, plus the immense high thermal conditions the Middle East is experiencing and will continue to experience. The shed. This was Hudson Yards, the largest private real estate project in US history. And you have the Heatherwick vessel there on your right-hand side, and on the left, the shed. And what the shed does is a telescopic building envelope that doubles the exhibition space, but critically, it's the show. It attracts people to this giant development, and only ETFE, with its lightweight and flexible building envelope, could allow this. Of course, we don't just work with engineers and architects, we work with people like Disney Imagineering. You can, so here's a 6,000 square meter complex building envelope. What else could do it? What could be lightweight, high span, still allow natural light, but at the nighttime completely change its identity? So what's nice about the ETFE, it has a daytime identity and a nighttime identity. So in the day, it's this silver, letting natural light in, but keeping that high thermal conditions away from you. At night, simple flood lamps, simple lights, LEDs on the structure allows the ETFE to glow and radiate like a beacon. This is the Arctic building, and what's interesting about it, it combines 8 existing private and public transportation systems. But critically, it was the first LEED Platinum transportation building in the world, and that was largely because the ETFE has such a low carbon footprint. It also, because it's 95% less weight, it gives you a much lighter steel structure. That means you need lighter structure, lighter foundations. So you've got savings top down in weight and embodied energy. And again, this building was the USA Public Building of the Year. It completely transforms those 6,000 square meters of ETFE in the day to this beacon of light at night. So what have we done in Malaysia? I'm going to run through, we've done a lot. Our latest project was in Kuching, in the Golden Triangle. It's hard to appreciate just how big the cantilevers are. So this picture on the left, I hope those 2 gentlemen there touching up the paintwork give you an idea of that 20-meter cantilever. And that's a single layer ETFE. It's not a cushion of air. Of course, a long time ago with Veritas, one of our earlier projects is the University of Reading down in Iskander. It's a naturally lit, naturally ventilated space. It's a breakout space for the students. The trees in there is almost a bit like a jungle now. ETFE allows the largest plant growth of all transparent materials. And the triangles you see are almost 7 meters long, you know, close to the size of this stage. We also worked quite significantly with Arabs. This is Aspen Vision City. It's 13,000 square meters of ETFE. And some of the drone footage. And what we did is we reversed the ETFE. It becomes a ceiling and a roof at the same time to hide the steel structure. I'm going to jump back to this at the end. This is Bukit Jalil, or Pavilions 2, as some people call it. This is the mega canopy. I will do a little case study at the end. One of our earliest projects, the British School, again, protecting children through the day from the elements. One of our most challenging installations was the Pavilions Hotel, 2 of the busiest roads in Malaysia, and we had to install the steelwork and the ETFE 85 meters in the sky with no access. We have some of the best project managers and construction managers in the business here. And again, these are real photos. It's helping to increase the thermal performance of the building envelope and help keep the outdoor atrium space dry. And many years ago, before this was added, every time the wind blew and you had rain, all of the connection at pavilions would be full of water. So we had to put this canopy in existing conditions. So we had to fix to existing columns and had to come up with a lot of strategies structurally and detailing to make it work. And in Bangsar South, before COVID, a lot of building activities. We did KL Gateway with 10 Design Hong Kong. And we had to do a lot of work. They wanted something that represented Malaysia, so it's your hibiscus flower. And we had to work out how to use different prints in the ETFE to symbolize the hibiscus flower. So track record, facades. This is a wonderful building. A shame the video doesn't work, but we've got a 15-story, essentially vertical luxury showroom. You sit downstairs, say you want the Bentley on level 12, and it comes to you. Fortunately, the video won't play. We're in the heart of London, part of the skyline. Bevis Marks, beautiful sky gardens. We take very utilitarian buildings and try and give it a bit more life. So at night, this exhibition center glows. And in the day, the natural light of the ETFE makes the entrance space extremely appealing. We don't just do big projects, we could do small areas like these facades where we're just highlighting particular parts, like here in Birmingham. Sports projects, big business for us is stadiums. Longer the span, the greater the advantage using ETFE. So Singapore Sports Hub is the largest spanning free dome in the world, 312 meters. Has a 20,000 square meter ETFE roof, which is also Singapore's largest flag. The roof opens and closes in about just over 20 minutes. This is in Dunedin, reasonably South Island near Christchurch. It is the first natural grass, fully cladded stadium in the world. The roof doesn't open, the pitch doesn't move, and it's natural grass. ETFE allows for full plant growth. In addition, this is a mix of sports plus renovation. Because ETFE is lightweight, we could add 2,500 square meter new facade without reinforcing the building, without closing Amsterdam's largest arena. And we changed it from a concave to a convex facade and a new window to the city. Clark Quay just went through a large renovation. This is almost getting close to 30 years old. Capital Land asked us to future-proof it. The ETFE was changed to allow for the ever-increasing heats that we're all affected by. So a lot more comfortable space. Now you can have basically 24-hour dining and entertainment venue. Very large cushions, very lightweight structures. And again, simple use of flood lamps on the columns gives it a different identity at night. Even the entrance canopies now, all by us. The jewel at Changi, right at the heart, is the Vortex, the largest indoor waterfall in the world. And even the drop-off canopies are all in ETFE. If you get a chance to come to Singapore, go to SJ Campus. You can go to the public spaces and see these amazing indoor gardens. Now, what's interesting here is not that it's just covered by ETFE, it's also the first cable stay structure in the region, no steel, 22 diameter steel cables spanning almost 40 meters. Resorts World, probably our largest project in Southeast Asia. Again, not just used for all the public spaces, but even in the Universal Studios. Education. Now, this is the largest preschool in the world, 2,100 spaces. Every breakout space where the children play is covered by ETFE because we could protect them from the UVA and UVB sun rays, which this client was particularly sensitive to ensure no future sunburns, skin cancers. We can put patterns into the ETFE so you can keep the structure quite simple, but then you can add the diamonds and the shapes that you want into the ETFE. We do a lot of work in high wind load areas. This is the latest project in Manila Bay. We even did all of the wind load testing. We did the steelwork, the engineering, helped value engineer the structure. And even though we're on Manila Bay, we almost got 500 kilograms per square meter wind load. Our engineers are able to do 35 meter spans, no trusses. Some of the lightest steelwork ever done in typhoon and seismic areas. And again, very, very simple, just on the edge of the supporting steel beams, simple LEDs. And what happens in a typhoon? Does the ETFE flap around? Well, maybe on an engineering level, tiny movement. But in reality, it just looks like a solid roof. We don't just do big projects, we do very interesting, elaborate projects. This is with Heatherwick Studio in Hong Kong. It's called the Ink Splat, and it is literally one giant ETFE cushion. Don't ask me the cost, this is artwork. It cost a lot. And when we do shopping malls, this is really our forte. Everyone wants the connection with the sky. Everyone wants high thermal performance and natural light. This is the avenues in Kuwait. 117,000 square meters of ETFE based on the global cities around the world. Some of the technicals. How is ETFE inflated? Well, that tiny box inflates everything you see in that picture. It's typically German, it's fault tolerant. Most of the time it's off. It inflates the ETFE to a set pressure, turns off and sleeps. If air escapes, it tops it back up. ETFE itself is transparent. We add our prints to the ETFE, and through those prints, through intensity and geometry, we can change the thermal performance. And basically, you can have the same U values as double glazing, triple glazing at 95% less weight. I'm just going to jump to fire here very quickly. As I said at the start, this is a fluoropolymer, it's not a plastic. What happens in a fire? It moves away from the fire, self-extinguishes, and makes a smoke vent. We've got all of we're on the Singapore product listing scheme. We've worked with Bomba here, no issues. And I'm going to say, just finish up, we're one of the most sustainable products you can have if you are very, very interested in having low carbon footprint, sustainable, recyclable products that perform. Come and see us. We're in the event space behind. Thank you very much.
Thank you, Matthew. We are going to have a 20 minutes break. Welcome back, ladies and gentlemen. As we are far behind time, let's not wait further. I'll introduce Timothy from My Heart Facade Technology to share with us about the design and the considerations in facade. Let's welcome Timothy.
Hi, good morning, everyone. It's good to see you again in this prestigious conference. Before I would like to start, I would like to take this opportunity to thank the organizer, Zak World of Façades, especially Ahmed, Strada, and the team. So this morning, I would like to present a high-rise facade, balancing aesthetic, structural integrity, and functionality. So this is the skyline of a beautiful Malaysia, and with numerous high-rise projects. Malaysia having the most high-rise project in Southeast Asia. There are more than 5 super tall buildings, which is more than 300 meters, and 2 more than 600 meters. Basically, the tall buildings are closely related to the growth of the city, especially in Southeast Asia. So this morning, we are going to discuss about the facade role in the building, design evolution, and design consideration from architectural elegance, structural integrity, and user comfort. The first one is a facade role. What is facade role in the industry? I didn't put this one by mistake, certainly. And there are 9 major systems for human anatomy. Very difficult language, difficult to be pronounced. And for me, the human anatomy is more or less similar to the high-rise project. For instance, the human skeleton, or they call it muscular system, is more or less similar to the building structure. And the main function is to provide the support. The second one, circularity cardiovascular system, or blood vessel, similar to the water supply, or we call it plumbing. This is a comparison between body system, building system, and its function. The question, what facade system is? We will answer it later. The second one, the facade is the front of the building. We know this one. Basically, the facade is the first aesthetic feature the building that distinguish one from another. That's the reason why big architect firm pay a lot of attention in the facade. And the most important characteristics that quantify and qualify the performance of the building. Second is the facade evolution from the tradition to innovation. This is very beautiful image. I like it very much. In the forefront is small, old traditional building, which is rich in detail, very complex, but at the back looks much simpler, but actually is very complex as well in terms of geometry and difficult in terms of technology as well. This is the first high-rise building in US, home insurance building. In here, the facade is a combination between a structural and architectural. In here, we can see the building beam, column, and so on. And there is a small piece of glass as infill material. But once the curtain wall was invented 100 years ago, the facade and the structure is getting spread. There is a separation between facade and the building structure. Everywhere is the facade. So we architects have more liberty to play with the facade. And this is a very common picture that you can see in Malaysia, 2-story, 3-story project. And the building also evolved in the height as well, getting higher and higher. Petronas Tower is one of the tallest building. It was the tallest building when it was built. It's a very complex, and Petronas is not for elevation, but they have a complex geometry, and it's create the complexity in the facade as well of its time. For the another complex building, also this building in Japan, Manhattan have been involved in many complex geometry building, not only in Southeast Asia, but also in the Middle East, in Jakarta as well. This building create very complexity on the facade, and we have to carefully engineering the facade. And glass is not predominantly used in the facade anymore. Example of this one. Architects have more liberty to find the material that can be used on facade. This is terracotta, which is now getting more and more common in the facade. Or GRC, precast panel. On the left side is Eden Residence in Singapore, one of the most expensive residences in Singapore. On the right side is King Abdullah Financial Center, where the facade is using glass, fiber, reinforced polymer. These two projects is Manhattan facade was involved. Another material that is very unique is woven rattan. Many years ago, I think this one is very famous in Southeast Asia, used normally for interior, chair, bench, and become increasingly popular for the interior, like a ceiling, partition. But we explore this material with one supplier for the facade. This is 2-3-story building, show unit apartment in Surabaya. And recently, we also involved in one project in Red Sea resort done by Norman Foster using this product. This product getting more and more popular. But a lot of things have to be considered. We need to consider about the fire. We need to consider about how to clean this one. That's are a lot of things that we need to consider if we are dealing with the new material. BIPV. Long time ago, what we can see, the BIPV looks, I have to say, is not really very nice. But the latest technology, we can have BIPV like this. It's very nice with a lot of pattern, color, and everything. So architects have more liberty to use this one as a spandrel area, even signage. We have one project that used this one, BIPV. We have to done a lot of things. I think I presented 2 years ago in this conference. In here, where is BIPV? The BIPV used in the top panel, top floor. There are 8 panels on the top, very small, but it's contribute 20.2 kilowatt power, which is quite significant for this small building. In Malaysia, we have this project. Part of University Kuala Lumpur is a net zero energy building, sustainable energy living lab. Just completed probably last June, last May, that's one. And the BIPV here is used extensively in the facade, in the signage, on the yellow one, the blue one, also on the roof. So here you can see a lot of BIPV. So the BIPV is getting more and more popular. I hope that we can use BIPV more on the facade. Another thing, the last is design consideration, from architectural elegance to structural integrity and user comfort. Certainly, the first thing that if we want to design facade is architectural issue. It's about shape, modulation, color, material, texture, and so on. But I'm not discussing in the detail because most of you architects know this one much better than I do. The second one, in the structural issue. I'm sure that you don't want to have this happen in your project. It's something happened in Hong Kong, 2018, and the wind speed reached to 70 meters per second. Another example is John Hancock Tower. Number of structural engineering know about this project. And when this project is built on 1971 to 77, the architect was IMP. The construction cost jumped from 75 million to 175 million, and surrounding street need to be closed up if the wind speed reaches 72 kilometers per hour. And 10,000 more glass have to be replaced, and it costs 7 million. And during the glass replacement, the plywood is used temporarily, and cynically they call this building plywood ranch or plywood palace. These two examples of the building that the facade didn't design properly. So another thing that we have to consider on the structural issue is the load on the facade. There are many load on the facade, acting load on the facade, snow load, wind load, negative, positive, and so on. Another also is wind load determined by calculation, which is come from different code, wind tunnel test, and wind tunnel test provide much more accurate. So if we have a very complex geometry or tall building, we strongly recommend the client to engage the wind tunnel consultant. And there are wind load is not happen on the entire facade will be having different wind load. See, this is a study from wind tunnel test. That's the reason wind tunnel test is important. There are certain area is much higher, especially on the corner, on the crown, sometimes on the podium, sometimes it's unpredictable. That's the reason why wind engineering is very, very important. Have you seen this one? You know this guy? This one is a 3-time world champion for the Formula 1. The unique story is the car industry, especially Formula 1, or the aerospace industry, consider wind engineering carefully. And that's the reason why sport cars have a very aerodynamic shape. There is no something rectangular shape sport car. Also aeroplane, or that's one, they have to consider the wind engineering carefully. What happened in the building? Actually, wind load also have impact on the shape of the building, or the shape of the building have impact on the wind study. RWDI Engineering, one of the most famous wind engineering consultant, they did study how to reduce the wind load. This is a sample, soften the corner, tempering, setback, and so on. This one, what they need to do, what need to be done in this project? They did tapering, spoiler at the corner, and opening at the crown. By doing this one, they can reduce the wind load significantly. Because this project is mega tall building, 600 meters, so the impact on the wind load give a greater impact on the cost saving as well. That's the reason why we can do something on the wind load. How about this project, Shanghai Tower? It's very, very famous project, spiraling shape. They did spiraling shape to reduce the wind load. The architect, structural engineer, then wind engineering study 5 different rotation from 210, 180, 150, and so on. And they found actually the most rotation giving more saving or cost optimization on the wind load. But the architect finally choose the number 4 and give 5% load reduction, which is save 10 million USD. 10 million USD is enough to pay the facade consultant, wind engineering, and so on. That's the reason this one is very important. A lot of load on the facade, something like live load, point load, surface load, other spatial load. Spatial load is very important. Sometimes we ignore it. Blast load, snow load, S load. We have one project next to volcano, around 5 kilometers from volcano, active volcano, airport, and we have to consider the S load on the road, which is 400 kg per square meter, which is very, very high. 400 kg per square meter. That's the reason why we have to understand this kind of situation when we design certain things. Another thing that we have to consider for the facade is building movement due to live load, wind, seismic, and everything. And this one, including the interstory drift. That's the reason why we always ask the structural engineering, what is the building movement criteria? Wind interstory drift from the other direction. Slab deflection. Thermal expansion. Another thing is also we have to consider column shortening, especially this one happen on the RC structure. Especially also if we have a very large cantilever. This will be very important. We need to discuss closely with the structural engineering. What is the behavior of the structural? And those will be reflected in the facade design, especially at the gap between mullion and transom. And sometimes we were requested to how to have minimum or omit this gap. It's very difficult, challenging, or impossible because this gap is required to accommodate the building movement and accommodate the load. This is how to calculate the joint. There are a number of criteria, which is we have to calculate carefully. And vertical joint. Basically, the aluminum have to move in certain direction. I'm not going to discuss this one in detail. Yeah. The next one, or the second item that we have to consider is the user comfort. Achieving the comfort, thermal, daylight, visual, acoustic, air quality, and so on. This is based on the study actually, 80% of adult and 90% of kids stay more in-house, internal, and this one is, the number is getting more and more, especially during COVID. Yeah. This is the diagram that I like it personally very much. On the right side is, on the left side is external factor, solar radiation, outdoor temperature, and so on, which is getting worse time by time. And human comfort, thermal comfort, energy performance, and so on, the demand is getting more and more. Yeah. So what happened with the facade requirement? Getting higher and higher. When we designed the facade 25, 30 years ago, I don't think we consider acoustic. We only consider the structure. We don't consider acoustic at all. But today, acoustic is very important. Thermal is not important, it's a must. Thermal performance is a must. But ironically, sadly, illogically, facade cost is getting lesser and lesser. And so what happened if facade cost getting happen? This one. The performance was not done properly. Or this one, leaking everywhere. So something like this. They didn't do facade properly. This is the reason of the facade is because of the facade. The fire is because of the facade material. So another thing that we have to consider is durability, facade work quality. That we need to pay more attention in the correct design, correct material selection, finishing, all the new material, we have to go through a lot of things, something like what we did when we use a woven rattan for the facade or insulation quality. There are a lot of problems in the facade if we don't pay attention, something like this. Or this one maybe, which I took it a couple days back. That's the reason why tests have to be done. Lillian and Michael did mention that performance test is important, but unfortunately, we have one project that the client want to remove the performance test, which is very, very bad. This is important for the performance of the facade. This is, again, there are a number of design consideration. I took the picture recently, last week. The picture is come from Petronas Tower, which was done 30 years ago. And something that impressed me, this building until now still very, very good and much better than the newer project, which is very, very impressive. So last time I always mentioned that the facade is a fashion, we can just this one, but now I don't think facade is only fashion that we can replace it easily. Back to the first question, what is facade is human anatomy. Facade, for me, is our integumentary skin. Our skin, our hair, and this one is very, very important to provide, serve, to protect, and to maintain. Again, if we want to be as pretty as this one thing need to be done. Maintenance. You need to maintain the facade. In Singapore, there is compulsory to have a facade audit. One thing is to ensure the facade is good, safe. Yeah. If we don't do a maintenance, this could be happen. Staining on the facade, at the end, this will grow up. If we have problem in the facade because it's incorrect design, improper maintenance, renovation on the facade is very, very painful. Something like undergo plastic surgery. So today I encourage to have proper facade design. Thank you very much.
Thank you, Timothy, for your interesting sharing, especially about the building autonomy and how the facade is as the skin of human body. Let us welcome Itay from Constantino to share with us the decton and how it is going to impact into our facade designs. Let's welcome Itay.
Thank you.
Thank you.
All right. Good afternoon, everyone. Thank you for having me here today. I'm from Constantino. Constantino is a family-owned company, a Spanish company from the south of Spain, known to be the biggest company in the world dealing with stone. We are present in more than 120 countries around the world, servicing our products, and the key on servicing. The presentation today is going to be focused on our jewel of the crown, decton for facades. Before we start, I want you to take a moment to imagine how we can transform the concrete jungles that today are mainly dominated with glass, that we know that glass reflects heat and actually contribute to the increase of heat in the cities, and to replace part of it with new materials. Decton, a product that is as durable as glass, with a flexural strength above 60 kilonewton, with zero porosity, which means that even in 50 or 70 years, will not change any color, will not get any scratch, easily cleaned just by wind and rain, and an absolute freedom of design. A product that can look like anything that the architect or the designer want to achieve in the building itself. Imagine that we change the skylines of the cities. Let's start with a short video. No? All right. What is Decton? So to keep it very, very simple, Decton is a blend of 20 minerals, inorganic minerals, that are compacted together in a process that basically mimics the metamorphosic process that happened in the earth of our globe, but instead of in millions of years, in a process that happens in one day. In order to achieve it, we created the world's biggest press, a press that goes up to 30 tons per slab. It's an imaginary number. In over this, you put these funny characters of 2.5 Eiffel Towers. 30,000 tons per slab is about 6,000 tons per square meter. By pressing the raw materials and then heating them together, we are basically following a sinterization that allows different particles to become to a new material. The beauty about Decton that we can't reverse engineer it. Decton is becoming a new raw material by itself, which means that once we crush it, we can actually use it as a raw materials for a different man-made materials that we sell. A little bit about technical properties. Look around you. Look at this beautiful natural stone that we see here, that everyone loves, but it's very difficult to use it as a skin of a building. With Decton, we can achieve it in a fraction of a cost, but with a much higher durability that any natural stone can achieve. And you can see in the small picture, a project in Chicago where the architect basically wanted to use exactly the same product to clad a renovation of a 5-story building, and we were able to achieve it with him with an amazing accuracy where all the veins are fully connected together in a book match process. So durability, UV resistant, of course, non-combustible. No one has the nerve to stand on this stage and talking about combustible materials, so purely inorganic, non-combustible. And stability, flatness, low porosity that eventually helps for maintenance. In the end of the day, when we look at the product, we don't just need the immediate cost, but how much it's going to cost us to maintain it 20 years to the future. And this is one of Decton's biggest advantages. As I said, multi-purpose. We are using the same product for flooring, for cladding, for countertops, but the real core of the product is for skin of buildings. Multiple thicknesses. Again, we want to be efficient with our energy consumption. We can use the same product with 5 different thicknesses, which means that we can start on level 1. We can use 2 cm thickness, which is great for direct impact. We continue with 8 millimeter, which is a much lighter material. But then when we reach heights in 200, 300 meters, where wind load can reach more than 10 kilopascal, we can switch back to 12 millimeter or 2 cm, depends on the static calculation. Environment. And this is key. We are all part of the construction industry. Latest research shows that the construction industry is responsible for about 1/3 of the global pollution. All of us needs to do one thing, one act, in order to improve it. In Costantino, we are taking it one step forward. All of our product, and specifically Decton, are purely carbon neutral products with cradle-to-grave certificate. All of the energy that we are using in order to produce the product are coming from renewable energies, and most of it come from our own photovoltaic farm. The biggest privately owned photovoltaic farm in Europe. As I said, we are reducing our carbon footprint. We are making sure to reduce the impact through logistics. As I said, we are delivering to 120 countries around the world, which means that when we produce a product, it needs to be carbon negative in order to achieve eventually when we ship it from Spain to as far as the South Island in New Zealand, it can be carbon neutral. Of course, it helps because as architects, as engineers, you can eventually help the developer to achieve the certificate with it, LEED Platinum or 7 stars. Colors, design. And this is where the beautiful part starts. We can customize the product to look like any product. It can be stone, metal, concrete. Many architects love to leave the building exposed with concrete, but it's great on day one. It doesn't look so good after 5 years. With Decton, we can achieve it. Of course, all the certifications. Because we are present in so many countries, we're able to bundle all of our certifications. By working with Miami, that is an area with hurricanes, so we're getting the NOA certificates through the European Technical Assessment, and of course, for areas that are more vulnerable for earthquake, all the relevant certificates. Now, Decton is the product, but the skin of the building is a combination, and especially when we are working with ventilated facade system or rain screen, of different subframe systems. And this is where we are working together with our partners, but also our own system, to make sure the Decton can adapt to any given system. Whether it's ventilated, it's rain screen. The beauty of the material is dense to levels, such a high levels that allows us to create back drills or back grooves that are purely concealed. For example, if we are working with a 12 millimeter material, we can work and drill it, whether it's 5 millimeter or 7 millimeter into the material itself, connect a fissure or a Keil screw in order to hold the Decton into its place in a purely mechanical system with no involvement of glues. So as I said, freedom of systems depends on the market, depends on the coding, but the beauty that the Costantino network allows freedom. We are working with all of these suppliers. We are certifying it according to the local codes. Here specifically, we can see the fissure system that is more known here. The Decton works perfectly with it. And the beauty about it, that it doesn't limit nor the orientation, nor the size of the slabs. Think that we can take as big as 330 by 160, 3 meters by 1.6 as one tile on the wall, and we can play with the orientation, with vertical and horizontal at the same time, because of the ability to hold the slab by its back. Again, ventilated system allows, because of the air chamber, to include also the isolation to the outside and decrease any thermal bridging with different barriers. Again, different system. I won't go very close. I will just scan it very through to see. We can drill the product in its back. We can groove it. We can manipulate it. As I said, man-made stone, but still stone, which means that we can miter it. We can cut it with water jets. Anything you can do with stone, we can do with this material. Again, different systems. Let's see a little bit project that we saw in these systems. So in this case, the Greenwich in London. Almost a 50-story tower with 10,000 square meters of Decton. And the beauty about it, you will see that it's not just vertical facades. In this case, we can even create different elements. And this is the beauty when I started by saying, Costantino doesn't sell products. Costantino sells services and solutions. In this case, there was a need to create already in our own factory these modules. They will be ready directly on site to be hanged to create like boxes that later also will be illuminated. And you will see on the left side the ability also to miter the product. Things that we can't do with glass and we can't do with many of the other products. So in many levels, Decton encapsulates the advantages that come from many different products, and Costantino were able to achieve it after working with many years with natural stone, engineered stone, and so on. Go fast about projects from around the world. This from Singapore, whether it's residential, high-res, multi-res, you can see that we can, again, do the cuts, different shapes. We are providing cut-to-size services, which means that we are not selling tiles. We will be together with you from day one through the design, the optimization of the tile sizes, and eventually everything will arrive on site like a piece of Lego to find itself to the right place in the building. As you can see, we can actually use it also for ceilings. Because when we use our lighter materials like the 4 millimeter and the 8 millimeter, we can clad the entire direction. Rain screens or curtain walls. The beauty about Decton that we can integrate it in the same model together with the glass. Because of the flatness, because of the flangeal strengths, in the end of the day, Decton is actually more similar to glass than to stone, which means that it allows us with the same elements to connect it in the same module. Now, why it's important, and I started with it. We can't have a building with 100% of glass. Many of the big cities today are limiting the amount of use of glass to 65 to 70% in order to prevent it. Also, in terms of efficiency, many times we are covering with the glass the spandrels, the columns. We are using multi-glass and so on just because we didn't have any other solutions to work with it. With Decton, we can achieve it. And then also we can allow the architects, the designers, to add more designs. Because what happened in glass in the last few years, we saw all possible colors of glass from green, blue, and so on, and it was in a very limited way our ability to change the look of the buildings. With Decton, we can achieve more. Coloring. In this case, custom colors. This one is in Sweden. They wanted the same product, but in 3 different colors that look exactly like natural stone. We can achieve it. Let's see a short video.
111 Eagle Street in Brisbane is a premium grade commercial tower, and the thing that we like describing most to people when they come to visit the building is the amazing fig tree column structure. So where they burst through the podium and come to ground, they're overclad with a luminescent white material which really makes them glow, and they become a really striking feature of the ground plane. Cox chose the Cosentino Zenith product for a number of really important reasons. The first reason really is longevity. We know the material is going to be here for a very long time, and that's really what we were looking for. The second reason is its incredibly consistent colouring and flatness. So it has a perfect specular finish which catches the light really beautifully, and it can be supplied in really large format pieces, made off-site, milled, tapered and cut with concealed fixings, which was really important for the project. So for all of those reasons, it was a great choice for us. Cox would definitely look to work with Cosentino again on our premium grade commercial facades, just because of their ability to supply an incredibly diverse range of premium quality products, which is really what we're looking for. And the fact that they can be supplied pre-manufactured, cut and tapered, ready to be fixed on site is really important to us. And I think the idea of prefabrication is really important, and it's where architecture and building construction industry is going in the future.
So I'm coming to my last slide, but just to talk a little bit about this project. This project weren't specified as the original version. The first product was specified there was some sort of an acrylic material that eventually were selected out because of the combustibility. And then when they needed to look for a new material that can meet the same characteristic, the same look, because they didn't want to change the design of the building, we were able to customize what they needed, but with a non-combustible product. So you can see in the last slide, the 8 points. Our involvement of Cosentino starts from day one, when you just conceive the idea of the product and we don't know yet what to use. And we asked our teams, and we have a team here in Malaysia and all across Southeast Asia. We are making sure to work with you from the drawing board and until the last tile was installed on site. We are present in the back. You're welcome to come to speak with us to see a little bit of samples. And next time that you think how we want to change our skyline, think Decton. Thank you.
Thank you, Itay, for sharing the wonderful product with us. Next, we will have our keynote speakers all the way from Singapore. He just landed yesterday. Let us welcome Aji from Broadway Malian to share with us the identity of facade design. Let us welcome Aji.
Thank you. Thank you, everyone. All right, good morning, everyone. I want to discuss about adaptive facade systems, balancing functionality and design to craft identity. And I'm Aji, Brahmono Aji, architectural designer and associate director from Broadway Malian, Singapore. So we are Broadway Malian. We are global practice, design collaborative practice. We based in Singapore. We have 14 studios across the globe, and we have master planning, architecture, interior, landscape architecture, branding, and graphic design. That shows how we want to really do a cohesive architectural or master planning or design on the project itself. So we work in multiple projects and also different type of project itself. So we have working in macro, from urban design, master planning, to micro, which is a small plots of houses. And we are around you, actually. So this is one of the projects that we did in Kuala Lumpur, the first financial district in Kuala Lumpur called Tun Razak Exchange. And we also did the Prudential Tower, which is the gateway of TRX. And this is quite exciting for us, and I would like to discuss further with you on this presentation. And the other side of Kuala Lumpur, we also did Sunway Iskandar. This is 10,000 square meters of 10,000 hectares of land, which we designed residentials and mixed-use development there. And we also did the first kind of catalyst building in this site, which is called Sunway Citrine Residence, which has residential tower and office podium. And recently, we're just working on this project called Bandar Malaysia, which is actually the place where we have the high-speed rail to connect Singapore to Malaysia. And we're really excited that this project is now being one of the projects that is shortlisted on a World Architecture Festival, which will be held in Singapore on September. And I would like to really talk about this statement and a question for myself as well, of how a holistic interdisciplinary design approach can craft and define identity using modular facade systems. And I would like to use these three projects that we've done in the region. One of them is the Google campus in Bangalore, and the second is the Prudential Tower, and the third is the Auraya Suites in Alam Sutra. So these three projects shows us the three different scales of project and functions that really try to achieve the identity and showing how we can brand the building through the facade and through the design itself. So I'm gonna start with this project, the Google campus in Bangalore. So it's located in Bangalore. Everyone knows it's the Silicon Valley of India. So a lot of kind of tech industry on this city. And we thought that the landscape and the context of this city being very interesting. They call themselves also the Garden City. So we take this idea of urban setting of Bangalore and inspired by the extension plan for the city's old pit area by Basavana Gudi, which has like a central square plaza, and it connects all of the activities around, with residential, office, parks, and some townhouses, which makes us quite excited, and how this actually connects to the idea of Google of having the dynamic flow workplace. So in these ideas of having everything together and get the central piece of architecture and space, and how this connects the activities around would be quite exciting things to explore on this project. So when we started this project, it actually consists of three towers. It has 4,000 square meters of tower each. But then Google came in, and we had that idea of how we can consolidate those spaces to be bigger and well-connected, kind of flexible office spaces. And this then show how we combine these three buildings into one singular 12,000 square meters tower. So imagine that huge tower is actually then create like a bit of challenge to us, which becomes quite massive. So we thought that we can think about the flow itself and how the landscape flow goes carving the building itself and being the gardens on the corner, and how these then the gardens on the corner later on will show on the facade of how people in Google using the space. So the facade is not just a static kind of element, but also showing how the dynamics of people that use the breakout space on each of the corner. Then this also gives us another challenge, because we have 12,000 square meters of space. The deep lighting penetrations being the challenge. So the way we do curving and carving the floor plate itself, it gives a natural light penetration a bit more, and the lighting inside getting better. And the second thing that we're trying to do, so we have three kind of design strategy we did on this building. The first is how the carve working for the daylight penetration. The second bit is how then we can also think about the section of the glass itself. So what we did here, we try to create like carve out the floor plate a little bit. So this has a light coming through, and the light cells will also distribute the lights penetrated in quite wider. And the third big thing that we do is how we can integrating this smart glass system. So we use the Sage Glass Harmony, and this really help us to reduce the glare, because of we try to give more kind of lighting coming through the building. This control your glare system on the building itself. So we give the thermal comfort for the Googlers to work inside the building. And the fourth idea that we have is we actually try to come up with the idea of indoor-outdoor working places, which I showed you before on the corner. So in this corner, we'll have like community space, breakout space, private room, meeting rooms that might also have like a double high spaces on each spaces. So this really way of giving a dynamic kind of facade, not just as a steel facade treatment, but also vibrant people walking and so on the corner. So we started with this, and we start to think about the challenge of how we can deal with the glass system itself. We understand that everyone just now talked about how the modulation will work on this building, on the facade architecture, but we thought that actually if we think cleverly, we can rationalize this facade system into one single facade length. Then that could be repeated. So what we did on the studio is how then we start to model it quite detailed with a physical model, and we start to think about what is the width that we can use on this building. So it's all using just one kind of a size. So this helps the modularity, this helps the constructibility, and this also apparently create a quite smooth kind of facade without, budget overhead the budget itself. So we thought that we quite happy with the result, and how this then becomes like the lights and the facade itself being static, and later on, once the landscape grows on the corner, this helps to get more kind of greenery on the side itself as a indoor-outdoor space area. And the Brahmono Business Park, this will be the home of Google, and will reflect the identity of people well-being with our corner gardens, and the casual interaction and collaboration among Googlers that we thought it could be reflected by the flow kind of ideas of this building. So the second project that I would like to talk about is this TRX building, which I found is quite interesting when we start to design this building, because we would like to really expressing the local identity of the building. And because this building being the first building on this development, and also the gateway of TRX master plan, so we thought that we can have three big ideas that we want to really achieve, which is the iconic, the transparency, and the responsive kind of architecture. So we started with this brief of a gateway, and we thought we can think about how this building being iconic but also efficient in some same way, and being the gateway to TRX itself. So we thought about these three kind of principles that we would like to achieve on these office towers, which efficient in floor plate, efficient in parking, and efficient in structure. But this gives a challenge to us, because every spaces will have different kind of a challenge and needs for the facade itself. So the lobby, you would like to have like open and as transparent as possible. Parking, you will need to have daylight and also natural ventilation into it. And the office itself, you will need to have like a simple and performative facade treatment. So we start to think about how we can use the contextual element to blend all of this together. So what we thought is, we got the idea of Tengkolok Diraja, a traditional head dress used since the period of Malay Sultanate. So we've got two ideas that we extract from here, which one is the triangular elements, and the second is the fold elements. So this idea then becomes quite exciting idea when we explore and we apply to the three elements of ground, body, and the head itself. So the folding elements could be on the ground, which open up towards the grand arrival experience. And the second, the triangular could be on the top, and the singular element needs to be on the facade of the main facade that is really giving the elegance of the building. So this then results on this unified tower with this distinct character. So really, we really want to emphasize the form of the building, being like the dress hat idea that we had before. And by doing that, we sort of think about the detail itself. So this is the building that's done now. So basically, we have three elements of it, like this folded facade treatment on the ground, which open up to the grand arrival experience, and how then it seamlessly changed into the podium parking, which we use glass kind of louvers on it. So then this seamlessly goes to the facade element, which all tied up with the vertical aluminum elements that also becomes the place for lighting details. And this triangular facade, we thought that quite successful, creating like seamlessly facade treatment that when you see from below. This is a picture that I took during my holiday last time in KL. So it's quite exciting how this then being won by the vertical elements. And at night, it looks really majestic because we thought that the lights and the pixelated emphasize at night and becomes very exciting. And when we have quite strong identity, this can be applied into other places as well. So one of them is the interior. So this interior is also inspired by the architecture. Also is inspired the landscape design. and the wayfinding itself. So from small bits to the big bits, when people come in there, they will understand that's a TRX building. So the identity is quite strong. And this is also the picture that I took when I stay in around this area. And I thought it's quite interesting to see how this unified architectural language seamlessly integrated with the urban fabrics, even with the Menara Merdeka. So those are the two projects, and I would like to jump into like a more kind of cute kind of project, which I find quite exciting. I work with Main Heart as well on the facade concept and also the lighting concept on this. So we thought the brief that we had before was actually to do residential towers. But these residential towers needs sales gallery. So that sales gallery, because we don't have any other places to put the sales gallery, that sales gallery needs to be seated on the site itself. So we thought we can have an idea of adaptable function there. Instead of just doing the sales gallery in the beginning, we put the sales gallery to be the clubhouse in the end. So this ideas of from marketing gallery to exclusive clubhouse being something that we really try to do. But this gives us another challenge of how we can have the two different kind of function that can be adaptable, but using the same facade system, using the same spaces itself as well. So the one thing idea that we had before is try to think about the facade and try to think about the relation with the urban. So what we had in the beginning was, this is our painting that we did in-house as well in the beginning, that trying to interweave the landscape on the facade. And this interweaving landscape really create the identity of the facade itself. And this also gives an idea for people later on that they come here and they want to get the house here. They would have a nice connection, indoor-outdoor space on this building from the ground to their amenities on the level 5. So this results on this facade treatment, which somehow we would try to mimic the idea of connecting the ground floor to the level 5 with this band of interweaving pattern. So just to give you some background, that this site position at the street corner and surrounded by multiple green spaces. The site actually offers potential views both into and out of the development. So we took the idea of park and the corner of the site and start to think about how we can make use all of those kind of urban fabrics and bring into our architecture. So this building is really contextual with the site. So we thought that the interweaving between blue and green could also actively connects the building and becomes the feature of the building itself. And how then the corner is very important. So we would like to really open the corner and having a really clear vista for people to come in here and see what's happening inside. And so they want to get in and get some thought about the development. So later on then this will have 3 towers. Once the building's built, then this becomes the clubhouse. So this clubhouse will connect the ground floor to the level 5, and we not stop on that, but actually the facade itself could also becomes the identity and applied on the building itself, and becomes one cohesive kind of architecture treatment. So we spend quite a lot of times on the jewel in the middle there, which we call the interweaving building clubhouse. So just this is the section. So basically we have a co-working lounge, entertainment, active quarter, and wellness amenities on top. This is after sales center done, but on the sales center itself, On the ground floor and second floor, actually, more kind of communal spaces where you have the sales and people wandering around, see the model and stuff. But the third and fourth, it becomes the office of this development itself. So we use that kind of idea and start to apply the thing, and how then we can then wrap the building later on with the facade, and how this then becomes a stepping kind of garden. So the idea of that wrapping is really also functional, because then we can cover the one that we don't need, which is level 3 and 4. But then we have level 1 and 2 being open to the corner. And we just use the very simple kind of glass facade with a layer of a pattern that connects the building itself. And at night is quite exciting, because we can see what's happening inside. There is a quite famous kind of coffee shop there in the corner, which has a lot of activities on the weekend. And we thought that this is quite interesting. And we just also find that when we do this kind of a nice thought of diagrams, people will easily get it. And this all being creating continuous facade language, that creating identity, but also engaging people to take picture of this development and share us on the Instagram. And I choose these 4 images because I thought it's quite exciting how people understand that the idea of interweaving between water and green being captured on these 4 images. And I would like to end this presentation by having this kind of idea that I believe if architecture is a language, then every building tells a story that defines identity. Thank you so much.
Thank you, Aji, for the wonderful presentations. I believe everyone is looking forward for the lunch break now, but before that, we would like to discuss something very important about the facade challenges. The buildings are getting higher, and the weather is getting severe nowadays. So now we are going to hear from our panelists the challenges that they are facing, especially in designing and implementations of the facade. As they were preparing the seat for them, I would like to call upon our moderator, Andrew from BFG, and together with the esteemed panelists upstage. Thank you. Let's give them a round of applause. Don't be so stingy. Yeah, Andrew, so you have all your panelists here with you.
Yep. Thank you very much. Hi, good afternoon, everyone. I'm Andrew Xia from BFG Consulting, the facade consultant in Kuala Lumpur. Very proud today we have good panelists to join me in this panel discussion. I would like to welcome my panelists. First of all, AR Elena Raman from DP Architect. And then AR Cindy Tay from ALT Architect. And AR Mr. Tan Shiping from SPIN Architect. So as mentioned, it's lunchtime soon. So let's get started with this panel discussion. With all my dear architects friends here, today we like to kickstart the discussion with the performance factor that drive the facade design, especially in this era of the post-COVID conditions. And then the architect trying to challenge each other with statements of better building, more nice looking building, plus with a lot of speaker speech before, with all this focus on energy efficiency, low carbon footprint. So what is the driving factors that push the design of facade? And then how do we design a facade with a long-term performance and also any innovation of materials that you guys like to share your experience with? Maybe started with Cindy.
Thank you, Andrew. I think Malaysia has a tropical climate. The architects, as like us, we need to consider the thermal insulation, energy efficiency within the design of curtain walls. It's also a balancing act to comply with environmental standards. And as we all know, the buzzword nowadays is ESG. We need to look again at more sustainable materials. Again, weather nowadays is getting more extreme, as we know, our environment is getting more harsh. And I think it's something that, luckily for us, we don't have any seismic movement, so that's one thing out of the way. But definitely, in terms of the performance of the curtain wall, the challenge for us is to balance what our clients want in terms of cost, performance, and timely construction buildability of the curtain walls.
Elena? Yeah.
Well, basically, Cindy has covered most of the topic. No, anyway, when we talk about curtain wall, the biggest challenges that we can say is about the cost and implementation of the curtain walling itself. Because curtain walling is not just the glass, the glazing, and also the framing system. It's about the implementation of system that you can open. You can make it into balcony. There are certain integration that we can have. We can do like openable windows integrated with the curtain walling. So there are a lot of possibilities. However, in terms of capex or costs that need to be put in, that is the issue that we have been facing, especially in Malaysia today.
I think you mentioned interesting about the ventilation, especially post-COVID conditions. Yeah, a lot of design is get driven with like better ventilations, with exchange of external and internal air quality. Yeah. How about Mr. Tan?
Due to the COVID condition we have for the last few years, natural ventilation for window is very important for living space, especially for high-rise building. I will also look at the natural ventilation for window in a high-rise building as a way to democratize the architecture, because you want to give the residents in a high-rise building the autonomy to decide whether they want to get in touch with the outdoor environment or not, just like their peers at the ground level. But you need to strike the balance between this natural ventilation requirement with also the window safety in a high-rise, especially child-proof safety requirement, because you don't want high-rise curtain wall window become loophole, safety loophole in terms of child safety or other aspect of safety. But Malaysia don't have a uniform rules yet on this item.
I think you mentioned an interesting point with the lack of the regulations to
Yes,
regulate the
it differs from one authority to another authority, but the fundamental thing is to make sure that the high-rise window will not become a safety loophole for high-rise curtain wall.
But I think that is a good news nowadays that standards are being developed further in Malaysia, in which lately, as of late, CIDB has implemented or make it mandatory that MS, if I'm not mistaken, 832 and also 1017, that it should be implemented to ensure the safety of the glass, to make sure they've gone through structural stability, and also the material itself meets the requirement. So those are the implementation regulations code that we have nowadays that will actually ensure that our glazing system are safe enough, are good enough for human habitation. So I think those are the things, the key things that good to be implemented, that has to be implemented, sorry. So the other thing is about code compliances. Nowadays, we have the Amendment 2021 in terms of our bylaw. So those, there is implementation in terms of BS 8414 facade testing. So if you have a facade that, that integrates together with, so for example, cladding material, so those, you have to comply to the testing. We are talking about high-rise here, so BS 8414 is a must. So 18 meter above is a must.
I think Elena mentioned a very important, good new developments in the facade industry in Malaysia, especially the enforcement by CIDB on the ACTA 520 for the MS832 and also the BAS 8414. Cindy or Mr. Tan, you have any difficulty or challenge when you start try to comply with the regulations in local context?
Maybe I will focus on the aspect of weather seal of the curtain wall, because in our works, one of the main challenges in tropical weather is to make sure that the weather seal components of the curtain wall is intact and also last longer. Because every time you get a complaint from the building management saying that the curtain wall have leakage during thunderstorm, this is the part that we can tackle and manage it during the process of shop drawing approval, careful review of the products of the weather seal component, and the detailing how they store the weather seal element. This is very important for tropical weather. This is the common problem that we face when dealing with curtain wall in tropical weather.
I think rightly so, the UBBL itself includes specific fire safety requirement. The code itself is there for us to interpret, but again, as A.R. Tan rightly said, like one of the speakers have highlighted, at the design stage, we have to ensure that the implementation, the downstream, is the end product that we want in terms of performance, permeability, water tightness, and all those things. So a lot of times there's a mismatch from how we want it, and then we say, okay, let's just rely on the subcontractor or rely on the supplier to do it. I think, again, like what I mentioned before, architects like us, we then need to work with the facade consultants, and it's our job to also sort of educate the clients and say, look, facade is like another thing. We architects cannot be relied upon to know everything, right? Isn't it? With generative AI, smart glass and all those things, technology is moving so fast beyond, what we can absorb on a day-to-day basis, and that is why you need a team of experts to be able to advise us and work closely together at the design stage to effectively implement the end product. And again, that boils down to what Elena was saying, the cost, because expertise comes at a cost, right? That's the challenge, I would say. Yeah.
Perhaps the key point here is actually collaboration. That is the word.
Correct.
Collaboration between you and the facade consultant, you and also the structure engineer in terms of wind loading. How we want to ensure the thermal comfort within this, the space itself. So we have to work with mechanical and electrical engineers. So collaboration is the key here when we want to ensure that the building itself works to the optimum level, but also that we have to always educate the client. And if we need to have certain requirements into the building, for example, we need to have facade testing, we need to have the water tightness testing, or mock-up. Well, mock-up is something that architects always insist of, and sometimes it was reduced to the smallest panel ever. I think those are the things that we have to share with the client. Please, let us have this so that we can get what you want and we can ensure that all the performance is met.
Yeah, I think it's great to acknowledge, I think it's a pain point that architects always get expected by the client and developers. Like, you are the architect, you're supposed to know everything. And with the new modern innovation and the higher requirements, it seems like ever-changing demand, and then you need a lot of new expertise and knowledge to fulfill and integrate all this into our design. And thanks for helping to promote our facade consultancy business.
We need you. At certain projects, we really need.
I think with my fellow facade consultant friends, later we shall buy them a big lunch. Okay, I think let's move on to another part of the topics in terms of like being an architect. With glass glazing facade and then unitized glass glazing facade, is always coming from this like Western, those urban design with all these glass building. But then in terms of like local tropical climates, and also to this like to deliver the statement of Malaysian culture, is there anything I wish like you can share your experience to the floor? Any personal experience, your design philosophy on how do you deliver the design into the facade?
Perhaps I'll share what DP Architects' ethos in terms of design. We always push for these three items, GWT, green, well, and tech. So when we are talking about green, well, tech, we look into the entire holistic approach into a design in which, for example, if we are talking about dealing with a tropical climate, so we are going to see what are the greeneries or the green elements that we will push into the project, up to the passive design, the orientation of the building, so those need to be considered. Well is about wellness of the human itself, the habitants in a building, and tech is all about utilization of technology. So it doesn't mean that if you're using curtain wall is much more westernized, it could be customized to our local climate and whatever that is to improve the wellness of the building user. So green well tech is something that we always push on and we always implement in our design for DP architects.
In our office works, we, in response to tropical weather, we always borrow ideas from traditional architecture, traditional Malay houses, traditional Chinese courtyard houses, even orang asli traditional huts. Because those precedents have been tested for centuries in the tropical weather. And we'd like to share two examples that we have done in a corporate office in Johor. Three sides of the building being cladded with curtain wall. When it comes down to fire staircases, we want it to be fully naturally ventilated to save the energy. But this decision normally comes with the dilemma of rainwater splash, security issues. So we borrow some ideas from traditional or asli huts, come up with the design which is called monsoon window. It consists of two panes, the window. The upper panes is placed slightly outwards. The lower panes is slightly inward. They will leave a small gap in between them. This gap is facing down. With this particular gap, you can keep the fire staircases naturally ventilated 24/7 without worrying about the rainwater and also the security issue. For the second example, we try to borrow ideas from these Penang traditional colonial houses. In those colonial houses, they have this decorative opening 2 feet away from the window. In Penang Hokkien, they call it Hong Kang, which is wind hole. It's a hole for the wind to come in. So we try to improvise it in the form of elongated, very slim and elongated opening with grill and wire mesh, and we place it at the spandrel unit at the curtain wall panels, and we face it towards the ceiling area. With that, we can ventilate the ceiling, and ventilated ceiling will keep the working space below cooler. And also, due to this improvised design, we keep our facade unique because no one have done it before. This is something that advantage of borrowing some traditional architecture and improvise it in modern architecture.
I think with lots of speakers today, also they are introducing a lot of like new material and new technology. Definitely there's a good opportunities that we can integrate a new technology into the more heritage and then our traditional building design concept. That will be very interesting to integrate the old design, but then come with the modern design and performance requirement. And Cindy,
traditionally, when we think about glass as a material and curtain walls, in our mind, it's modern office buildings, and rightly, as what my colleagues mentioned, we need to take cues. Being in a very tropical climate, you want daylight, but you don't want the heat, right? You see, so you sort of have to take hints from our vernacular architecture, sort of like introduce, when you think of the glass as a skin of the building, to integrate with sun shading device, deep overhangs. When there's rain, you want to have, ventilation, but you don't want the rain coming in, right? And our rain is not vertical, our rain is horizontal rain. I've seen overhangs with 20, 30 meters, and yet when you're standing with a 20, 30 meter overhang, the rain will get to you, right? Some of the terrace houses, if you're not careful and you don't have a deep enough overhang, your entrance will get wet, right? It happens all the time. So I think, again, it's a balancing act because our weather condition is so harsh, right? And you want to think of glass as a material, but also to supplement it with the design of sun shading device and overhangs to complement it in a way.
Yeah, okay. Yeah.
Maybe I would like to chime in some additional point. Other than the weather element that we put in consideration when we design the curtain wall, one of the other parts of the consideration would be the well-being of the occupants inside the enclosed curtain wall. For example, with application of low E glass, you can reduce the glare of the curtain wall. And with the reduction of glare, you can reduce the, you can get minimum eye strain, and also with lesser glare, it will soften the living space environment. You soften the mood of the living space and also working space. With that, it will become more conducive for the occupants' mental well-being, and also it's good for productivity if it's in the office space. And this is very much in line with ESG goal, which is popular at this moment.
Talk about ESG. This happens to me years ago when I was junior architect. So when we look into getting score points for our GBI, for example, Leeds, or during that time was Green Mark, GBI wasn't in yet. So we were as a young architects, we focus more into the performance, not really considering the actual daylighting in the building. For example, we want to achieve points, we want to make sure the solar coefficient is good enough to balance with the energy efficiency. However, in terms of daylighting, it doesn't work. So for architects, right, again, when I mentioned earlier about testing, about the mock-up unit, is to ensure that what we want in terms of performance meets the design of what we want in terms of user-friendly and also the comfort within the space. So I think those need to be considered because I see a lot of young faces here. So just to share something that I had before as a young architect.
Yeah. And then with all this design intent and then the performance requirement, of course it come to lead to the more sensitive, most important topic is how do we control the cost and budgeting? I think everyone loves to share some thought about this idea. We always like to have the best design, best performance, but after you all design, the costing comes back. Then any strategy or experience and any tricks to deliver what we intended to have with the acceptable budget, with a good ROI and deliver to the clients the best interest?
Well, costing is a dirty word for architects because you always bump into problems when we come down to costing issues. But we have a few tips we would like to share with the audience First, it's a good practice to obtain the initial budget from the client so that you can set the direction right. The second would be, if you really burst the budget, maybe the costly facade area, you can make it in a smaller scale, make it like a soft landing, and push in with some cost-benefit analysis. Let them see the value. So if they're okay with it, maybe slowly you secretly push the boundary. Later on, you will get slightly bigger scale to achieve your architecture ambition. And the last one, don't take no as an answer. Take it as, okay, we go back, we'll do the value engineering. Because there's always the room for value engineering. With value engineering will help you to keep your design concept intact. We just shove off some of the other elements.
I think, Andrew, you used the wrong word. It shouldn't be cost cutting, it's value engineering.
Some of my clients use value enhancement.
Value enhancement.
Yeah. When it comes to budgeting, right, we have to make sure that the client knows we design in such a way, the client loves it, but we have to preempt them in a way, the cost estimate really need to be done much earlier on. And basically the project team need to be very careful, especially before the tender stage, to make sure that all the requirements are met, all the requirements are spelled out, so that no surprises later on. At least during that time, right, if we need to do VE, it needs to be done. But sometimes I think that, budget is one thing. When a client said, no, you need to work this out, that is where the fun begins. Because during that time, you really collaborate and you really work with your project team, your facade consultants, your M&E, your engineers, on how to make it best, how to present the design in the best foot forward. So I'll always take it as a challenge and take it in a fun way. Think about that lah. It may not always be a fun way, but it could be.
Yeah, I agree. I mean, just like one of the speakers have highlighted just now, you may use a more expensive product, but if you can cut down your construction time by half or even 30-40%, you get back everything, right? You launch earlier, you sell earlier, you get your rental back earlier. You know, so at the end of the day, it's a cost-benefit analysis like what Tan highlighted, right? So it's our job to educate, to convince our client to have that meeting of minds between us, the facade consultant, or even the contractor or the supplier that's, actually coming up with the system of the curtain wall, right?
But sometimes good design doesn't need to be costly.
Sorry?
Sometimes good design doesn't need to be costly.
True. Yeah. And also being a facade guy myself, sometimes I also totally agree with what you say. It's like the real cost is not purely on the material cost itself, but then in terms of when the project setting the budget is always purely on what is listed in the BQ. So like a lot of project people actually lost the emphasis in delivering the better system and then construction buildability, where all this is not simply and easily presented into the form of BQ. So a smarter, well-coordinated construction program, and also the system, how to install it, and then in the future, the better way to maintenance and minimize the cost of the operation. That's where the real money and real saving is. But then, unfortunately, I think either our project is too rushed, and also people just rely on the piece of BQ and calculate the cost in that, and people just paying too much focus into the material itself and lost the focus into where the bigger money saving can be. Yeah.
Correct. I mean, anyone from the construction background will tell you that if you look at the entire project holistically, you might cut some savings here and there just by cutting down time, right?
So yeah, just now you mentioned about not cost saving, it's a value engineering. Sometimes I mention it's not soul searching, it's pocket searching.
Sound better, fancy word. Sound more fancy.
I'm happy that this topic doesn't come out. And now it's a client bashing session.
No, we are not.
But it's good to have
It's okay,
you
I think
sharing-
some of them are not here, so it's okay.
Yeah, but it's good to share your thoughts in this one. Yeah. But another topics I like to cover would be on those like in local Malaysia context, like the requirement of the compliance. Just now, Elena did mention about the enforcement of the ACTA 520 and then also the 8414 in the fire safety. However, being a facade guys, like I used to work in different overseas country. Things that I found that in local context is like we don't have enough emphasis in the compliance, and the authority doesn't require, for example, like a main building, you need a structural engineer to do a sign off and submission. And then architect, you need to sign the G form. But then in terms of facade element, being the exterior of the building, the first thing that fall off the building and injured someone, it's actually never been paid enough attention in terms of like engineering compliance, and then like who is responsible for like severe leakage and then loss of the thermal performance. Like, how do we improve the local markets in terms of like enhance the compliance and better regulation?
In our tender for glass or curtain wall facade for high-rise building, normally there will be a terms to require the contractor to have the shop drawing been signed by a PE, which is a professional engineer. This is one of the safety steps, because architect, your knowledge is limited. You need somebody to take responsibility.
I think the system we have CCC, where there is a matrix of responsibility but applied on. So those actually help as well, because it's not just designer, there's also the implementer, whoever that builds. So there is some matrix of responsibility. But of course, every time we want to sign CCC, I always take a day and sleep on it, and tomorrow I will sign, because it's always kind of nerve-wracking whenever I sign CCC. I don't know about you guys, but I do have that kind of nervousness. I think in terms of implementation, this is why they say architects is somewhat a jack of all trades but a master of none. So we always have to ensure that at least everyone in the team plays a part. So in terms of compliances, we also have to ensure our cloud of works or our site staff really knows what are the designs, what are the compliances, so they can actually monitor the site. They are our eyes and ears at site. So in terms of the drawing checking, PE endorsements, all those we need to ensure that is in order. So in terms of project management, is very important for us to ensure at least compliance are met.
I mean, you talk about codes. Our building bylaws were drafted, what, in the 80s? You know?
Based on some even earlier.
You know?
There is
Or
an
70s?
Yeah.
So even our MS standards. So are the codes all encompassing or not? You know?
They are being developed.
You see? So it's not all encompassing, isn't it? Right? So half the time we rely entirely on whether the suppliers to tell us that they comply, isn't it? You see? So that really there's not enough, like what I said previously, even in terms of enforcement or compliance, it's until something happens, like a building catches fire or a piece of glass falls off, then somebody will jump up and say, oh, hello, we need some code. Something like that. You know what I mean? Yeah.
Yeah. It's not just Malaysia, it's all over the world, I think.
Right?
Yeah.
So it's not all encompassing. So at the end of the day, we as architects, we do our due diligence, we try our best, to get the whatever information, whatever testing that needs to be tested, gather whatever certification that we can get on paper, but realistically, at the end of the day, the execution on site, did the client get what he paid for? Again, everybody has to play a part. There's a doer, there's a checker. The doer must not try to cheat the checker. right? Isn't it?
It's a not cat and mouse game.
Yeah. So it's a collaborative effort, to bring the thing to fruition at the end of the day, right?
I'd like to add on that. Again, come down to our uniform building bylaw. There's a few gray area. One of it will be the fire-related building bomba requirement. For example, for curtain wall, normally the cavity between the curtain wall and the building structure is the area for the fire to spread. And our since last year, bylaw 144 amendment, the so-called the curtain wall and also aluminum composite panel have been split into two different categories of fire requirement. And these two components also under two different set of certifications. So if you have, if your design combine both together, you have to be mindful of two different set of category of fire requirement. And when it comes down to fire safety responsibility, it's better for you to include a fire stopper in between these two different materials. If you have a curtain wall together with ACP, aluminum composite panel, with that you can set the fire liability line clear, just in case anything happens. But this particular aspect of discussion is not appear in any of the bylaw or MS, Malaysia standard, BS requirement yet.
So that is the difference between fire barrier and also fire stop, right?
Yes.
Yeah.
Previously, there's no difference, but now specifically under two different certification, two different serum testing, and two different set of certificate. This.
Yeah. When we talk about design, we always always mention as a design as overall form, but then we also like to emphasize design including the further understanding of how to install and the future maintenance. So for Mr. Tan, you have anything to share in terms of this?
Yeah, there's okay, maybe we'd like to share one of the main challenges in installing a curtain wall. If your curtain wall is under fully unitized systems, there will always be a problem in terms of alignment because you're putting a prefab components onto in situ components. There's bound to be some accuracy issue. So one of the so-called popular terms in curtain wall contractor discussion is Sao, which is close the gap. So to manage this problem, I would advise you to have a stick system at every critical point so that you can adjust it in situ to make sure you can reconcile the different alignment that come from the factory. That will be some thought on the installation later.
So in terms of curtain walling, when we do high-rise curtain wall buildings, there's always one factor that the client always asks us, is it necessary? For example, building maintenance unit, BMU, gondola, where is always preferred to be the abseiling type so that we can save on costs. But it depends on your design. If your design is complex enough, you have undulating facade. So maintenance is one big thing that we have to consider because there's no other way to clean the facade. At the end of the day, we want to make sure our city is vibrant, our city is well manicured, so-called. So as architects, specifier, we have to push through in terms of the building maintainability, need to always remind and need to always emphasize that is required. Whatever system, building maintenance unit that we are going to propose, please learn about that, please understand about that. Those are important.
True, totally agree. As us, when we get involved in the project, we always prefer to get in early stage together with the architect, so we can integrate the design with planning for future maintenance. that they will last for a long-lasting, high-performance building to keep the integrity of the whole system. I think like we're running out of time. I'd just like to wrap out this discussion with invite each of you to share being an architect in the market, what do you see as a future trend for the facade in the next decade?
Actually, I'm very excited. I mean, looking at some of the materials that were presented today and also the future trends, I believe there's a great potential in generative AI, dynamic and adaptive facades, and all this will actually propel the industry forward, so that we can, again, like what Elena has mentioned, we can add value. The facade is your face, right? Isn't it? That's what I tell my clients. You better take care of your face, right? Isn't it?
Yeah.
So I think the Internet of Things, technology, AI-driven, all these things at the end of the day is going to better inform us on how to design and execute in a better manner. And I think it's a very exciting future for all of us, especially for all the young architects out there. They can be more innovative, provided stick with the cost lah. Right?
Well, I'm a bit traditionalist. Instead of looking into the future, I will encourage fellow architects to look into our past. There's so many ideas that we can borrow from our traditional architecture. Malaysia is blessed with various ethnic groups. They have their own architecture that we can borrow from. And we can improvise many methods of construction out from this traditional architecture and apply it in our modern architecture. And the result will normally be, your facade will end up with very interesting feature, and also will stand out among the rest because you are trying something that no one had tried before. And normally when you improvise something, the possibility can be endless.
Echoing a bit on what Architect Tan has said earlier, I think about the vibrancy of our culture is something that I'm looking forward to, because when you look into the utilization of AI, advanced or enhanced PPVC usage, someone can actually personalize their space much earlier on before they get the key. So for example, those are the things, the potential that we can see in our city, that it is no longer like, you can recognize this is Malaysia. It won't just be like, oh, okay, this is a metropolis. It can be anywhere, but it can be personalized. It can be vibrant because each and every one of the building users would have the opportunity to personalize it even much earlier on, utilizing the AI. The input is very much faster. We were talking about earlier before this session today with Architect Tan about the dream of designers, that we have a lot of responsibility on our head. So if we could have a checklist, right, like an app, to say that, oh, okay, our design is compliant to A, B, C, D, E, F, G. So those are one of the tools that can actually speed up the entire process. So yeah, for me, I'm excited of the future. I'm excited of how the city can be much more vibrant, because our cultures are, we are not monotonous. So that is my hope.
I mean, I think it's also not just in the design, but also in the manufacturing of things, and in the fabrication. You have digital tools like 3D printing, parametric design, CNC machining. Our manufacturers are also, in that direction. Then we can actually have very intricate and very customized facades, right? So working together with them, the future is definitely clear. Very bright for them, right?
Yeah, thank you very much for the sharing. And then we like to end our panel discussion here. And thank you for your input. And I believe everyone on the floor will get some new knowledge and insight with this discussion. Thank you very much.
Thank you.
Thank you.
Thank you. Thank you everyone for the informative discussions. Please stay on stage. I would like to announce that there is a lunch break now. Every one of you can enjoy your lunch outside. We have delicious food waiting for you. Just have to repeat it because some of you just joined us now. Please take your seat and let us welcome Qayyum from GDP Architects. He's going to share with us about transformative architecture. Let's welcome Qayyum. Please give a round of applause. I think you have more energy now after the lunch. Welcome, Qayyum.
Hello. Good afternoon, everyone. So I believe everyone has had a good lunch. I hope the coffee is strong for the next few sessions. Thank you, everyone. So for today, my name is Qayyum, and I'm from GDP Architects in Kuala Lumpur. And I'll be doing a sharing session about transformative architecture. Okay, my pointer. So I'll be talking about transformation, covering about 4 projects, looking into transformative material, transformative in building form, and transformative in mindset. And the projects are generally more modest, as compared to the Dubais and the Twin Towers of the world. It's a bit more small scale. In fact, our clients are generally the smaller humans, which are kids. So transformative in terms of the definition of transformative architecture reshapes the traditional notion of a building design. And its importance is in terms of enhancing the experience, also sustainability and integration of technologies. And the objective as an architect is to innovate the spaces, especially in relation to educational spaces. So the first project that we were fortunate to be involved in is the Permata Pintar, located in UKM, in Bangi. And the concept is more about the initiating of a singular form that is broken down into, according to the contour, organically derived through the abstraction of the site's natural valley and surrounding forests. And so the sloping nature of the site sort of integrates with the building formation and enhances the campus. So it's basically a school, a secondary school of 12 to 17 years old. They are generally genius kids where they have the potential to be developed and they will be doing their theses and they are going to be the think tank of the future. So the school actually has a program that sort of promotes them into Ivy League, the pathway. And the brief was actually to design an auditorium for the kids, for the students, and a sports park. And so it involves about a 600-person capacity auditorium, and generally for lectures, for schools' musical theater programs. So it's a bit of a different kind of syllabus as to the normal Malaysian school system. So the contextual analysis is, that's the site. It's located in the UKM compound. So the operator, Mata Pintar, this was the first phase. This is the building that they operated prior to when we came in. And their request was, please don't change the building design. I mean, like, please follow whatever that we have here, right? They kind of said that this is something that we are proud of. And so unfortunately, we took it the other way around and we totally disregarded that request. And so we started off with the spatial planning, looking into the usable spaces and how we can, use the contour. And the conceptual sketches where it's generally made out of like 3 boxes to accommodate the required spaces. And the idea is basically to just give a different experience or a different branding to the school. And this is the floor plan showing the 3 sort of boxes in a sort of linear shape, and the section that how we incorporate the auditorium, and within that 3 sort of boxes. So the outer skin, it's basically a cladding system. We have two internal and external skin. And so the material is made out of aluminum composite panel and ventilation blocks on the inside. What we wanted to achieve in terms of the visual impact as a striking appearance that fosters inspiration, identity, and creativity. So these students are aspired scientists, engineers, maybe architects. And so we wanted them to have a sense of playfulness as well. I mean, not just about studying, but also about being able to explore and to think beyond what is conventional. And so this is during construction where we had the ventilation blocks as the skin on the inside, and then we have the external cladding on the outside. And so this is the elevation where we can see the open joint ACP panels, and there are some spaces that goes inside. We explored patterns through colors and also through, for example, the adding visual interest by having pattern ventilation blocks to add some sort of cultural or thematic experience. And the geometry, form, and custom design motifs was incorporated. And as seen both interior and exterior of the design is how we implemented our ideas. And so the inner skin is actually ventilation CMU blocks, which also acts as an acoustic wall. And so part of the strategy was, with the set of budget, how can we better utilize the impact? And so our approach was actually to make it a bit more modest on the inside, but having spent a bit more on the external part. At the same time, we wanted some sort of haptic experience for the kids. So as compared to like a normal plaster paint wall, what is the experience of having something a bit more raw for the students? And on the other side is the sports park, where it kind of has the same idea in terms of the flowing of the site. And as you can see, there's a swimming pool, and also the green part is actually an informal sitting space for the kids to be the spectator. And this is another view of how we actually blend the sports park within the environment. The idea is actually to achieve a minimal disturbance and a buildingless form, where the green sort of continues from the hill into the roof, and then the roof becomes another roof for the other compartment. And so this is the elevation of the building. And what we wanted to achieve is also the idea of the roof becomes the floor for another space, and the column also becomes the beam for another space. And so this is the view from the green field and the jogging track. And this is the floor plan showing the integration of the landscape within the building. And so part of the idea, as mentioned, from the entry point, so if we're standing at the entry point, it's actually at the highest elevation. So it drops down. And so what we wanted to achieve is the continuous view towards the green vista. And so that's where it sort of slopes down. And this is the elements that we played along with. So going on to the next building, which is a nursery, done for small kids between 2 years old to 6 years old. And we wanted to study the innovative learning environment where childhood education, we wanted to see how we can actually impact the building or the environment. And so our vision is to create nurturing and stimulating environment for young children. And the key features includes curvy facade, vibrant colors, and interactive spaces. And so this is one of the slides that we presented to the client. And part of our approach is to look into precedent studies around the world. And what caught our eye is one of the projects that was done in Vietnam, where due to the war period, they had a lack of green spaces or a lot of lack of farming spaces. And so they wanted to introduce farming or the idea, the notion of having greeneries within the learning environment. And so we took that as part of our strategy. Some other features include a continuous walkability or continuous path within the school. And so those are some of the key points that we took in terms of freedom and flexibility of movement. So for example, the kids, when they go out of the classroom, they can go to the bathroom through different circulations. And so that's the idea of freedom and flexibility. We played around with colors because we feel colors gives a certain experience or mood to the kids. And also, as mentioned, circulation. And so this building has like about seven or eight cylindrical blocks. And the important feature is also the spiral staircase and the slide. In both of the projects I'll be showing, the slide is an important sort of entry point for the kids. So as a young parent, I believe the morning is actually the hardest for us because we have to bring our kids in and they always have different agendas in the morning. And so this kind of experience of showing a play area is important for the environment of kids. And so in terms of the floor plan, as you can see, it's all actually connected externally. So what we wanted to achieve was also the courtyard in the middle, and they could be moving between the spaces in a more open environment. At the same time, we wanted that sort of visual connection so the teachers will be able to see where the kids go, and the entry point leads into the internal courtyard. This is a diagram showing some of the key ideas that we presented to the client, materiality, and also how we divided the active and quiet zone. So the quiet zone is generally at the top floor for the babies, and then the more active is at a certain area. And so we studied color and the generation of color. Thank you, Jotun, I believe, was our supplier. And the benefit of flow and movement and also the central courtyard was achieved through this project. So pattern and textures was added to promote sensory and stimulation. Another project that was done at the same time, we had P14 and P11 in Putrajaya. This one was a bit different, but in terms of the spirit was the same. And so this one was more emphasized in terms of the movement. And the same idea applies in terms of we wanted the kids to be moving about from classes, from areas. And part of the study was that children who moves throughout the day actually has a better mood. They're able to actually calm down rather than being stuck in a classroom. And so for P14, the idea was to emphasize on fluid pathways along classrooms, the bathroom and the play area. This was also the slide that we presented to the client, which showed the concept references to give the client a sense of reference, and then space distribution and programs was allocated. And materiality, we looked at materials that is comfortable for kids, and we know that sharp angles and hard materials is actually not friendly for the kids. So those are sort of the things that we looked into, those curvies, fluid areas. And as mentioned just now, we divided into quiet and active zones. And this is the view from the drop-off where we achieved the same sort of impact in terms of making the school looks like a play area and to get the kids excited to go to school. And another important aspect is also in terms of scale. So we recognize there's a sense of being in control. So kids like spaces where it's more, the scale is appropriate to them as compared to in a normal environment where they actually feel overwhelmed, for example, in terms of the chairs or the door or the handle or even the sink itself. And so being able to introduce these sort of spaces gives a sense of dignity or a sense of familiarity to the kids. And so this is what we also put priority in. Yep. And so I think it's fortunately it was a good project for us because normally we would do commercial high-rise. Those are our bread and butter. But these are sort of the projects that actually is closer to the heart. It gives impact to actual people or actual small human beings. And so we were very fortunate to be getting the Gold PAM Awards for the auditorium and silver for Sports Park. And we got the same award for in 2020 for the Nursery P14. So what are the challenges and lessons learned within this project? The common issues apply, which is in terms of budget constraint. So clients that come to us doesn't come with an endless budget. They always have a certain set of budget, especially for high profile sort of projects. We need to make sure that it doesn't go beyond what was approved. And so the strategy or the outcome that we got out of it is actually to capture the big idea. So especially with this kind of projects where it's connected to high profile, for example, the Pembantu Pintar, we had to do the presentation to the Prime Minister then. And so we only had that one chance to blow them away. We have to give the big idea and to make sure that it's implemented. And so I think coming back over the years, what we think is a good strategy is always give your best shot and make sure that you're able to impress them. And then the budget could slowly be, accommodated to your ideas. And secondly, I think transforming the idea is how we sort of have to strategize. So within the big idea, you need to strategize to make sure that how do you manage where is the buffer where you can play around, say if you want to spend at a certain bit at this much, which part is actually something that you can compromise or you can sort of look for alternatives. That would be our lesson. And my final thought is about on future of educational architecture. I think the trend is towards sustainability, flexibility. Post-COVID, it's no longer about rectangular classrooms with a certain window facing into the courtyard or facing into the corridor. It's about integration of landscape, about integration of indoor and outdoor. And the innovation actually comes from emerging materials. So I think as architects or the industry players, we need to always be in line to what is happening around the world and to utilize the new technologies. Integration of indoor and outdoor, I think it applies not just for education, but I think it applies to all sort of environments where students, especially for students that are grouped within a certain classes daily, weekly, a different environment actually encourages participation or encourages better learning experience. So with that, I end my sharing for today. Thank you.
Thank you, Qayyum, for sharing the wonderful school project with us. I wish I can study there, actually. It is a reality that I couldn't, but now we are going to welcome Richard from SZ Facade. He's going to share with us the theory versus reality. So, Richard, it's all yours. Please let us know what is reality. Don't wake us up too much.
Good afternoon, everyone. Theory versus reality. Have anybody thought what should be this topic all about? Now we are always posed with so many new challenging designs. So as a facade engineering company, we need to understand whether the theoretical part of our work can be done into reality or not. An example is like this. If you are a creator and you have this kind of design, and then suddenly it will come out not according to what you have, will you be happy enough or not? So this will come in, wherein the role of the engineer will help out in order that the creator of that design will have a happy ending or be pleased with the design. Now, it takes a lot of faith to the architect in order that will come into reality. So as an engineer, we have to make sure that we will be of assistance to the architects in order that that theory can be applied into reality. Today we will be discussing some simple engineering designs, like structural facade components. We have some simple facade, we have some typical facade, we have some complex facade. In the screen, you can see there's a simple facade. On the other side, on the right side, that means on my left side, that is, I will call it a typical facade wherein it's just a continuous unitized curtain wall. There's also such designs such as complex, wherein there's a curtain wall and then suddenly there is some incorporation of a glass wall plus a combination of sloping wall in and out, and even there is some canopy that is attached to the building. So how would we approach this as engineers? We have to take note of some very important items that we will be discussing shortly, right? Mainly, the facade should have, the function must be considered as well even when we do the design. The impression of the architect or the artistic intent of the architect or the owner must be achieved. We need to make sure that it can provide resistance against various weather conditions, considering that weather nowadays is always an issue. Air, water, thermal comfort, acoustic, and fire. We have to consider all these things. And currently, many designs now are getting into green, and then we have to have an insurance that it can be an efficient energy saving that will be compliant to the codes. And some parts we have to make sure that the facade will also serve as a part of renewable energy. As time goes by, there are so many types of facades, materials that are coming in and out, and facade systems. So everyone from the industry come out with his own system, window glass, thick wall, unitized, and so many terms that have been used in the market, right? Others will call it lightweight, heavyweight, and so on. But for facade materials, we have many facade materials nowadays that are in development. But of course, the glass panels we cannot avoid. There is always glass panels that are going on, innovation through new technology. There are aluminum composite panels, perforated panels, GRC, GFRC, GRG panels, and so on, terracotta panels, precast panels, stones. Now we have the engineered stones and the natural stones, many others, as technology is improving day by day. What if you have a simple yet complex design? This is a very simple facade, but with a bit of complicated design. It is sloping, it is twisting, it is curving. So without the use of modern technology and the ability of the facade engineers, it's difficult to achieve such design and install in the site. We need to have some technology moving around and the capabilities of those engineers that can be able to accommodate the design of the architects. From the design point of view, we need to ensure that these are compliance to standards, to codes. That's why safety analysis is one of the important part of the design that the engineers must do. We need to look into local standards, international codes, and we have to perform structural analysis. Design codes, what are the codes that we need to do? Local codes, we need to ensure that we are compliant to UBBL, CIDB, PPS, CIRIM, MS, BOMBA. Our RC structures must improve our compliance, steel structure, aluminum structure, and even glass. And most importantly, sometimes that we miss out is the establishment of deflection limits. Deflection is very important, wherein we make it to ensure that our facade are compliant to these deflection limits to avoid structural failure. After that, we have to ensure that we will set up a design criteria. Design criteria will guide us along the way, wherein we have to control the limitations of the building. One of the examples is that we need to have a wind loading to be established, which is always the main issues wherein someone will say, oh, I want the wind load to be like this, I want to have like this. So it's very important that we need to have compliance of the codes. Currently, in Malaysia, we normally use the MS 1553 or BSX 399, but for a building which are huge and large or tall buildings, it is highly recommended that we go into wind tunnel testing. Wind tunnel testing will be giving us some accurate results. It will be good for saving as well. It can improve potential with maximum floor space, it can insurance, and for increase in litigation protection. Now, how does it look like? This is an example of what a wind tunnel test report will look like. It will point out to us which one has the higher wind load, which one has a lower wind load, so it can help the facade engineer to ensure that it is not only compliance with the codes, but can be able to do some value engineering with the correct and results that we are having rather than those we are doing without the wind tunnel testing report. After setting out the wind loading criteria, dive into your technical specification, which we need to identify our scope of work. We need to identify what are the items that need to be done, need to identify the design life of the structure, the performance warranty, movements of your building, movements of your slab, thermal movement, floor plate, and even the concrete. These are to be coordinated with your facade engineer and also with your structural engineers. So from there, we are going to develop a system design that will be suitable for your building. So most importantly are all these the movements are being catered for by your designers. It is very important, otherwise if there is some movement that cannot be catered, there will be failures in your facade. Your engineers should do a structural analysis, whether it is complex, whether it is simple, whether it's a combination of both. Ensure that these are checked properly by your facade engineers. Do some glass analysis, do some ACP analysis, do some mullion analysis, transom, sealant, all these small things must be checked. Now, what if your building will have a very complex design wherein you have a facade and then suddenly there is a canopy that will be covering it or attached to your building? Having this kind of design, you will have a lot of movement that you'll be expecting. Without the proper design, this building will just collapse. It is a going in and out. You have to make sure that your glass is compatible with the movement of your building, compatible with the movement of your steel. And it is through coordination with your facade engineer, with your civil engineers, with your CNS engineers, in order for you to make sure that these are done properly. What we can do is we have to do some practical simulation of the building, what will happen to it. We have to make sure it can be panelized, make sure that it is possible to work on rather than just simply making it a theory, but we just make sure that it is possible for you to work on. So there will be new technology that are being improved day by day using Rhino, using Grasshopper, and so many softwares in the market right now. Now you have to do some crash analysis if needed. You have to ensure that all the details are being covered in your design and even in your preparation of the tender drawings. Let us now proceed with constructability. Before you construct, of course, you must take note of your costs. It is very difficult for you to make a certain building. You want to create something iconic and then you don't have that enough costing. You need to have some clarity of your scope of work. You have to have modeling and make sure you have some technology consideration. And in your construction, we suggest that you have to have the right manpower, you have the right machineries. Your contractor must have mastery on their type of work. Constructability. We can always do a digital mock-up before proceeding for a final mock-up. It is very important as well before you spend too much to have a digital mock-up to ensure that these are able to be manufactured, able to be installed, can be done or cannot be done. Performance mock-up is very important. Visual mock-up is very important. For performance mock-up, make sure that your building can be able to pass air, water, structural, proof load, and whatever other requirements that the facade engineers would require. From theory to reality, now this is something that we will go beyond BIM already. What if your building will be something like this? Your facade will have a double curved curtain wall, it has a double curved cladding, it has perforated panels, double layer metal roof, and it has some ETF tension membrane. What will you do? Before you spend too much money, you have to dig in, get the right people in to ensure that it can be done. So perforated funnels for that project, it was modeled, it was put into action, and then we were able to confirm that there are a few panels that can be maximized to a certain numbers in order that it can be accommodated. So from this project, there are some perforation that needs to be done, like 15%, 20%, 25%. So all this must be performed first before you go into production. So how would you do it? You do a panel study. We have to check what happened, if can be done, or it's still going in and out, or there's some wastage. All this can be done using Grasshopper, using parametric design and custom design. From 15%, 20%, you have to ensure that these are well accommodated in your design of that system. We also do check the purlin system, do some paneling using Rhino, using Grasshopper, and we do check the number of unitized panels. When you have those quantities, you may dig into deeper that it may need to be more customized in order that will be less wastage. So you need to have some consideration in the technology that you are having. You must have a powerful modeling software. You make sure that your modeling is also, there's an accuracy, and make sure you have some collaboration among your team that everyone can do these projects before you dive into construction. So software selection is very important. For this project, we use Rhino in URBS system in order to model the whole thing. Grasshopper and different script program can be used in order for you to visualize your building. So building of a model. BIM model is built for that project using Rhino and Grasshopper. So it will be presented, studied, and make sure that building can be done. Put in more details, put in very important parts of your building, very important components in order for you to make sure that everything can be done perfectly, can work properly. Otherwise, it will not be as what you are expecting. So after all these details are put into place, do a crash analysis, detect and analyze whether there is some clashing that is involved, whether when you go for installation, it will be done accordingly to the drawing or not. Your theory can become a reality or not. You have to do some crash analysis. And on the construction part, we need to do some 3D scanning. We need to ensure that your contractor or the facade contractor has enough manpower to ensure that they have the latest technology before even awarding to them. Now, this is your dream. Everybody wants to have a dream. But what if your dream will come out to be a waste? So we suggest that you better have the right people in order for you to have that dream into reality. You need to have the right people for the right job. You have to have the right technology. You have the right equipment. You have the right machineries. Your contractor must have the mastery of the work to ensure that they really need to know their work. You need to get involved your facade engineers if necessary in order that your dreams can become a reality. That's all for today. Thank you very much.
Thank you, Richard, for showing us the reality in the facade world. We have been using a lot of laminated glass due to the safety requirement lately, but very few of us know about the interlayers and how it works. Let us welcome Ron Howe from Kurare to explain more about the interlayer and its technology to us. Welcome, Ron, to the stage.
Hello, my name is Ron Hull. I work for a company called Kurare. We're a Japanese company. I'm based in the United States near a city called Miami, Florida. So thank you for letting me speak today. And what I'd like to do is, I'm going to be talking about two laminated glass inner layers. So I just wanted to pass out a couple samples. So I'll pass some on this side and this side, and I get just zigzag back down. I think it's really important you understand the difference between the two. Okay, my agenda today is a quick introduction and to talk about some innovative structural applications, some amazing structural glass projects, and then we'll talk about sustainability at the end. So our company makes safety glass inner layers, and they're used in many different applications, as you can see here, but the two I'm going to focus on today are structural security and sustainability. What is laminated glass? I assume you know this, so I'll go through this pretty quick. It's basically two or more pieces of glass with an inner layer in between. And the main function of laminated glass is really safety. If the glass breaks, you want the glass to stick to the inner layer versus flying around in a car or falling off a building. The two main inner layers are PVB, and our brand is Trosaful, and then ionoplast or Century Glass. So those are the samples that are going around now. So what is structural laminated glass? Well, there's many different definitions, but a common one is it's a frameless glass assembly where the glass is taking on an element of the structural load. The structural laminated glass really began when DuPont introduced the Century Glass Plus inner layer many years ago. And one of the first companies to adopt Century Glass and structural glass into their buildings was Apple, and you'll see a couple slides in here. So what makes Century Glass so unique? Well, first of all, it's 100 times stiffer and 5 times more tear resistant than PVB. It's very clear. As you look at the samples, PVB has a yellow tint to it, where the Century Glass is totally transparent. Really good for low iron glass. Century Glass is very durable. We have a natural weathering station in Miami, Florida, and we now have 26 years of data where the edges are exposed to the environment and still look great. Impact resistance, whether it's a cyclone or a tornado or hurricane, or even some sort of security, Century Glass is very good against impact resistance. Century Glass is compatible with most sealants. PVB sometimes have an issue with sealants. Post-breakage strength, I'm going to show a video on that. And then design optimization. You can actually use thinner, lighter glass makeups using the Century Glass, which results in lower CO2. So what is Century Glass versus SGP? There's a lot of confusion about this, but basically Century Glass Plus was invented by DuPont in 1998, about 25 years ago, for the hurricane market in the United States. Many then called it SGP. DuPont dropped the plus from Century Glass Plus, and then it just became Century Glass. Then in 2014, DuPont sold its PVB and Century Glass business to Kuraray, a Japanese company. All the patents, trademarks, and equipment. So today, Kuraray is the only company that is legally licensed and by patent to offer the Century Glass materials that were invented by DuPont. So also, if you're a structural engineer and you're doing calculations, the authentic Century Glass performance data that's available on our website should not be used if you're looking at using a counterfeit SGP. So to make it simple, we'd recommend you specify Century Glass or SG by Kuraray if you want the high quality Century Glass materials. Okay, so there's some projects out there where the counterfeit SGP was used. This is a big one in China. It's an airport project. And it looks like the glass is broken, right? But it's actually the SGP that's laminated in the glass that broke. I don't know why, but maybe it went through some sort of high wind load and it cracked inside the glass. So this is just one project I want to highlight. Okay, now for structural glass applications, there's many, as you can see on this chart. One is a glass floor. These are very, very popular everywhere now. As you can see, the glass was broken, and these people are standing on it, and they're still safe. This is a video we've been using for years, showing the difference between tempered glass and laminated glass and century glass. So the first glass being broken here is tempered glass, standard tempered glass. So the nice thing is when the glass breaks, it breaks into small pieces, so you're less likely to be cut or injured. However, it's now off the building. If you put applied film or stick-on film on it, it keeps the glass together, but then it falls on the ground as one piece. Here's PVB. PVB, as you see, almost no glass falls off the building, but however, it folds over like a wet noodle, and so now it's no longer a safety barrier, like if it's a glass railing. And then here's century glass. You see that the glass does break, but then the century glass pops up, and it's a barrier until it can be replaced. Okay, now in the United States, there's a lot of testing for security. So in this test, you shoot the glass 5 times with a bullet, and then, so it's not bullet-resistant glass, the bullet goes through, and then you beat on it until it's failed. So on the left is PVB, and on the right is century glass. So here we go, we shot each 5 times. So first you throw bricks at it, and you can see the PVB is already started to crack. And this is the kick test. This is actually what people in the United States do to break into a building, unfortunately. You can see the PVB failed, it popped out of the frame. So this piece of glass here, if you see the really thick century glass, the thickest one that's going around, this is the actual glass makeup. So I think it's 4.56 millimeters of century glass. So this test goes for 12 minutes. You switch to different tools over 12 minutes. Sometimes these people get tired. There's a joke that in the United States, people who are in anger management programs, this is what they do. And then he finishes with a sledgehammer. So anyway, this went through 12 minutes of tools. Glass was broken with bullets, and there was never a tear in the inner layer. Okay, so now let's talk about some amazing structural glass projects. Here's some monumental ones you're probably aware of. But one of the first structural glass projects ever with laminated glass was this retail store in New York City. It's called The Cube. And this was 2005, but then glass sizes started to get bigger. So this company actually remodeled it with big glass. So the transparency really increased just by using bigger glass. In New York City also, on the top of one of the tallest buildings, in 2005, they put a glass railing. It's 3 meters tall, only supported in the shoe. And it's a nice windbreaker, but the glass is still there, and it looks great today. And then and this is in the Grand Canyon in the United States also. It's one of the first cantilevered glass skywalks. So both the railing and the glass floor have century glass. So if you're afraid of heights, some of these projects you're probably not going to be interested in seeing. And this one just south of here, the Sky Park on the top, the whole Sky Park had a nice glass railing installed back in 2010, and I was there this weekend and took a picture, and I tell you, the edges and the glass still look great 14, 15 years later. So it's very, very durable. Okay, now in Paris, the Eiffel Tower remodeled the first level back in 2014. So here I am looking through a glass railing down, and then I'm standing on a glass floor. There's a ceramic frit there. So This is a good example of a floor and a railing. Back to the United States in Chicago, someone decided to take a window out of the tallest part of a building and put a glass cube. So you can actually just walk right onto this cube, and it feels like you're actually walking on air. And then also in Chicago, there's this, this is actually something you can rent, and it tilts off of the building. So it kind of feels like you're falling off the building. There's a nice observation deck. So you stand there hanging on, and you slowly are falling off the building. It's quite a sensation. And then in Los Angeles, this is a cool project. Someone decided on the tallest building to put a glass slide. And I've done this many times. It's actually pretty fun. And it lands onto a nice observation deck. And last year in Dubai, they actually put a bigger slide in at a higher elevation. So next time you're in Dubai, there's something similar there. Okay, and the last project is a suspension bridge in China. You can see, it's strong enough to hold a car. And there was an extra piece of glass, so they actually broke the extra piece of glass on top of the bridge, just to show you how strong the glass is. And you're safe. And then here's in Bangkok. You probably saw this nice skywalk, relatively new. And then my last project this is in New York City. It's a new observation deck, really nice glass floor and glass railings. And then here in Malaysia, the TRX Mall, the crown up top has really nice structural glass. And then last time I was here, we actually had an event at the Banyan Tree Sky Bar. All those railings have Century glass. And then most recently, I was here yesterday. This is a store that just opened up in the TRX Mall. And then actually the entire mall inside has Century glass in the railing. So it's a really, really nice project. Okay, I'm going to skip through these and go to sustainability. So like most companies, Kuraray has sustainability goals. We want to reduce our emissions by 30% in 2030 and by net zero carbon emissions by 2050. Our company now has completed LCAs and EPDs for our products, and they're available on our website if you're interested. But in general, what we found was PVB has about 12 to 19% more CO2 than a similar thickness of Century glass. So we're also working on a new low CO2 interlayer. In October, we're going to be announcing. So we've been trying for years to reuse laminate glass by separating the interlayer from the glass off a building, but there's still too much glass remaining, but we're getting very close. But ultimately what we want to do is to remove the PVB, remove the Century glass from the glass, and then reuse it in our factories as a raw material. So I think we're getting very close. Okay, so to summarize for structural glass, just by switching from PVB to Century glass, you're using lower carbon, lower footprint. And then you can down gauge glass. So I have an example. In one case, instead of using 16 millimeter glass with PVB, you can only use 12 millimeter glass with Century glass. So you're using less glass, less carbon. And then when the glass is lighter and thinner, you may need less metal to support the whole structure. And then you can also remove glass, you can also remove metal from the framing. Instead of 4-side captured, you can have 1 or 2-side captured. And someone mentioned this earlier, the Shanghai Tower. That was a great project. Both walls have our Century glass in it. And here's a quick example. Well, it's the third tallest building in the world, at least the last time I looked. We ran all the calculations. So if this building would have used the curtain wall, PVB, it would have had to been 15 millimeter by 15 millimeter. But by using Century glass, they were able to get by with 12 millimeter by 12 millimeter, which means you needed less steel and aluminum to support all that weight. So ultimately what we found was just by switching from PVB to century glass, you got a 20% CO2 reduction. And then here's another quick example showing 8 millimeter, PVB, 6 millimeter, century glass, where you ended up with 24% reduction. And then on my last chart, I mentioned you can reduce metal. So on the left shows a glass railing, old glass railing with four-side capture, so metal all the way around. And on the right, you have a nice glass railing, it's only supported in the shoe, no glass on the other three edges. So no metal on the other three edges. So that's it. Thank you.
Thank you, Ron. As our buildings are getting taller and the people are getting more and more adventurous, safety is always our main concern. Let us welcome our next speaker, who is also going to talk about safety, but it's fire safety and sustainable facade. Let's welcome Jaka from Trimo to give us the presentation.
Thank you. Good afternoon, everybody. My name is Jaka. I'm representing Trimo activities in Southeast Asia. It's always lovely to come back to Malaysia. Today, I would like to present a fire-safe and sustainable prefabricate solution for building envelopes. Who are we? We are Trimo. We are a 63 years old factory and leading provider in Europe for building envelope and roof solutions. Today, I would like to talk about the sandwich panel produced from 3 layers, external metal, internal metal steel sheet, and mineral wool between. So we are tailor-made manufacturer of the panels that are needed for the project. We produce in different coatings, different colors, different thickness, size, what is needed for the project. We produce and ship directly to the construction site. So what performance you can get with these panels? Our panels can have fire resistance up to 4 hours. You can achieve very good thermal isolation, all down to 0.15 watt per square meter Kelvin, depends on the thickness. And what is very important for Malaysian climate, very good water tightness and also air tightness. So if you have a good air tightness, since all the buildings here are all the time under air conditioning, this means that not losing air through the cladding means a lot of energy savings. Of course, this material provides you also the sound isolation, and what is most important, this is green material. So it's 99% recyclable, produced with very low CO2 footprint, and mineral wool itself is non-hazard waste. Yeah? So again, you can generate a lot of points in case you want to achieve LEED or Green Building Index and so on award for your project. We have a lot of certificates all around the world. Most important probably is FM insurance certificate. So if your investors wants to have lower insurance rate later, our material can contribute to this. We comply, of course, also with Malaysian BOMBA standard. We are doing CRIM tests and, of course, CIDB. Few words about the fire safety. When I'm talking around with the architects, consultants, it's still a big mess what means fire-safe material. And unfortunately, we still see a lot of cases like, okay, Greenfield Tower, we all know, but for example, you are having more and more data projects, data center projects in Malaysia. This is one case from France. They really secure totally the building. Nobody cannot enter cybersecurity, but on the end, they use combustible cladding and data center burned to the ground. 2,000 website gone and a lot of data gone. So that's why I would like to present you three fire properties of the panels that you need to consider. So first of all, we are using A1 non-combustible mineral wool. And once we add the glue and the gaskets to get the water tightness of the panel, we as a panel, we are classified as A2 limited non-combustible material. A second, how this material reacts in case of contact with fire. So our material do not contribute any additional energy to fire to spread. Because of mineral wool inside, there is no toxic smoke coming out from the panels. And because we are using metal, not aluminum, there are no fire droplets coming out from metal and cause more fire to spread. And then the third category, the most important one, is fire resistancy. So this means if we build a wall from this material, for how long the fire do not enter the other side. So we classify this as EI 120 to 140 minutes. So this means that in 2 hours, this wall will not collapse and also fire will not enter on the other side. This is how the test is done. So you do, you have a chamber with huge fire behind. You close this chamber with the panels and you do the test and measure the temperature on the other side. This test standard is also applicable in Malaysia. Otherwise, in Malaysian context and sandwich panels, we need to comply with two things. So in case the building is lower than 18 meters, material needs to comply with class O. And then if the building is higher than 18 meters, we need to comply with BS 8414, which is new regulation in Malaysia. What is important to understand is that even if you are classified as class O, this don't mean that you need to use non-combustible material. How this test, so how to get this class O is very simple. You take the material, you burn it, and then compare with the non-combustible material results, and then you measure also the spread of fire, and combination of these two results can bring you to class O classification. And then a little bit more demanding test for the buildings higher than 18 meter is BS 8414. It's very important. This is 1 hour test that is actually checking the spread of fire and also chimney effect behind the panels. This test is also 60 minutes test, so it's very important that we don't mix this test with the fire resistancy of 1 hour. Why even to use prefabricated material for the cladding? So with prefabrication, we can ensure very high quality of production. We can use automatic machinery to produce material, and we can also check raw material. We can check material during the production and after the production. Very quick installation later on the site because it's less work on the site. Of course, this material is produced in the weather control atmosphere, and later is less effect on this material during the installation. Of course, also much less wastage on the construction site and also during the production. I would like to show you this comparison how to use the sandwich panels. So most of the time we are comparing this with a traditional system when you have a brick wall, some isolation, vapor barrier, and then steel structure that support aluminum cladding, for example, as an external skin. So all these elements can be removed and you can use a panel which will provide you quite long span, so means that you will reduce the steel structure behind. You have a one system, one subcontractor, one warranty, And you get the fire-rated, water-tightened, air-tightened external facade, and in most of cases, by industrial projects and warehousing, also internal wall. So a lot of advantages comparing with the traditional system, and of course installation is very, very quick. Short video, so with very simple equipment, once the main structure is up, we can close and water tighten the building. Panels can be installed directly to the steel structure, or in case of the concrete structure, you just need to ensure the leveling, the flatness behind, and then you attach the panels and close the building. And of course, also with the panels, we develop all the details, so you can integrate the windows, doors, especially by data centers, you have a lot of penetrations. And we develop all these details, how to do it in a way that this material is fire safe and also water tightened. I'm very happy to share that in Southeast Asia we are present more than 15 years already, and we have actually projects all over the Southeast Asia. And yeah, in last years also quite few in Malaysia. So this material becomes more and more popular in this region, also especially because allows very quick installation and also later adaptation of the building. I want to show you one more, some references. So here, for example, we see office part and behind logistic center with small manufacturing area. So also this silver part that it looks like aluminum cladding is actually the sandwich panel, more advanced. It's actually prefabricated from all sides, so no flashings between connection, but on the blue area you have the standard one, and yeah, you can see how this is closed. So on this project, actually it was concrete structure. We did also the beam modeling, visualization, and then later cladding with Trimo panels. This is how project looks on the end. Also internally we use the panels. So sometimes we can simply leave the columns visible, or you can do additional cladding from internal part with the sandwich panels. We can span even up to 10 meters, so floor to floor. Again, a lot of reduction of steel structure and very easy installation. And yeah, I would like to present you also a few references. So as I mentioned, we a lot supporting data center project, semiconductor industry, and also pharmaceutical industry in this region. Also data centers like to use these panels because of a lot of penetrations. A lot of equipment is outside the building, so it's very easy to do this, and also to adapt later the building if it's needed. But otherwise, this can be used for all smaller showrooms, warehouses, high-rec warehouses, logistic centers, heavy industry, shopping centers. So a lot of option of using sandwich panels. This is, for example, Airbus plant in Germany. Using horizontal, so we have options of different orientation of cladding.
And one example also from Singapore, applied material. This was actually the recent project from Singapore. That is all on short from my side. I invite you to continue also outside. We brought some samples with us, so I welcome you to visit us and see also this material with your own hands and eyes. Thank you very much.
Thank you, Jaka, for your wonderful presentations. I saw many of you are struggling to stay awake after the lunch, not because of Jaka, of course. You may now proceed to have your coffee and tea outside. We are having that, or stretch your body, whatever you like that make you feel better. We are going to have a fun time as Jeffery from Architect 61 is going to share with us the fun with Facade. Let's welcome Jeffery on stage.
Good afternoon, everyone. I hope you all had a good coffee break. I will just start. I think we are running out of time. My name is Jeffery Ling from Architect 61. I thought after a whole long day session, sometimes maybe a bit heavy, I thought maybe I go in a bit of lighter mode of fun with Facade. I will not, they are probably categorized in 3 subtopics, but they will not be in any order because I will be showing some of the examples of our work. Basically, they will they will cover architectural and aesthetics. Basically, you know that facade and cladding influences the architectural design, right? And it also defines the identity of the building, right? The identity of the building. And also the various facade and cladding materials complements the various architectural styles that is present in the market. Of course, then the functional benefits, you all know sustainability, weather protection, insulation, and screening, and how these are put together to make it into a beautiful building, basically. And of course, sometimes there are influences of certain influences of cultural and social significance that need to be incorporated into the building. So I will just briefly touch some of the 3 things that we have in some of the jobs that we are doing. Mainly will be continue Ek Kia Ping, Troika, Kota Baru, to a certain little extent, UOB Plaza, Lakeview, and Pano. This building is actually in KL, Long Jalan Tun Razak. It's actually 2 towers, but you see that there's something like 6 towers there, right? 47 stories and 50 stories. So we have articulated the whole building. And you can see on the right side, there's the Pudu Market. So it's the only modern building in a very old neighborhood. And if you look at the site is actually by coincidence, it has a butcher-shaped knife. Just by coincidence, that's the site that we have. So we have to deal with the site and how to design a nice building. And of course, we use, because the site is in a more rhomboid or trapezium type of shape, so we use that as an inspiration. And again, if you look at just now at the market, we have a lot of umbrellas, right? The umbrellas are also in that shape. So we use it as a point of reference in our design. And that rhomboid or trapezoid shape, we rotate it, we tilt it, we stretch it, and we put it in a 3-dimensional form. And that is the facade of the car park podium. The shop lots are at the bottom, the 3-story shop lot with the glazing and the office. Again, you can see the umbrellas of the market at the right-hand side on the top, and they are all in triangular shapes. And we use that because the umbrellas are in pitch form, right? So the planes of the car park, we use perforated and solid panel to create a 3-dimensional effect. And it's very stunning when you drive along the road. And it gives a lot of shadow and light as different time of the day because of the play of sunlight. And again, during the last panel discussion, budget is very, very important, right? And again, in Malaysia, you know, we are all architects. Developers said, save cost, save cost, save cost. So instead, we try to accentuate the whole building. You know, so what we have done is that the edge of the building, we clad it in ACP only, not the whole building, to give it a bit more classy look. and again, to bring out the whole architecture. You can see the planes by articulating the facade in terms of more three-dimensional shape. Instead of your typical flat facade of an apartment, we tilt the planes subtly and create a more dynamic form. And again, we incorporated sun shading louvers into the unitized windows. We got no curtain wall here, unitized windows. They can be, because of unitized window system, we can replace it from inside, no need to replace our outside. Integrate with sliding screens on the eastern side and western side for sun shading. Now we have, these are the spectacular architecture elements that we have on the roof. The one in the center, sorry, back. The one in the center is a sky deck. The one on the top, the highest most, is the sky lantern. And the one here is the sky lounge. Basically, we have repeated the three-dimensional form into a sculptural form. The sky lantern, again, becomes the beacon of the building. The sky deck have the unimpeded view of KL skyline. And the sky lounge becomes the entertainment hub of the residents. So there you can see we have a portal frame, and we have designed with the contractor a three-dimensional facade system into this two-story height sky lounge. And that's the internal sky lounge. It's very, very dynamic. You can see the TRX in the background, right? That's the upper level, and that's the lower level. Is in three-dimensional form. We work in details with the contractor to conceal all the joints so that you don't see all the ugly bolts and angles and that's present in most of the design. That's the sky lantern on the rooftop. In the same format, we are using perforated panel, again three-dimensional. It's hiding all the services, all your water tanks and various things that's on the roof. It's hiding all those things. And it doubles up as architectural, sculptural lantern at night, where it becomes a lantern, a big shining beacon of the project. And that's where you have a view of it at night. All right. Next project, 8 Kia Ping. This one was shortlisted recently, one of the top 5 in Architizer worldwide. Again, how we use facade to accentuate the look, the sculptural look of the building. That's the main entrance. It's a very tight site, 1 acre site, 50-story and 450 units. Again, very dense, high dense development. Again, we're using ACP for the podium and also for the guardhouse cladding. The building is on the. This is the building, if you can see, and of course that is the crown and a penthouse and a sky club right on top. Again, the whole building is partly cladded in bronze ACP, which we work with the coating people to a certain color, because the building is facing KLCC in the evening sun. And that coating, we have also worked with the coating people, whereby there's a bit of sparkle, so that at different time of the day, the bronze, you will see that it's shimmering and shining, right? So we have to work closely with it. And these are all in one single color, because we have a budget constraint, all in one single color. But because of the three-dimensional shape of the building, in terms of the cladding to the podium, car park podium, and the tower, you see shadows and lights, and you see some shades, and so you see various type of colors throughout the day. So you see that the facade is dancing in that sense. So it's quite interesting. We use extensively Revit in the office. That facade that you saw, the podium, you cannot draw it in two-dimensional. So what we have done is we draw it in three-dimensional model. We gave it to the contractor, and the contractor will come back to us with their constraint. We work with them on constraints, because there's always a limitation in terms of the panel size and also the site constraint, because the site is very tight. The other thing is we need to comply with Bombang compliance, 40%. So you make sure that your openings are sufficient to comply with your Bombang compliance in terms of natural ventilation. So the one on the left, you can see, are all the sectional drawings. The one on the bottom right is the models, and the one on the top is the elevation. So we work extensively in three-dimensional forms. So if you can see the facade, we again articulate in more three-dimensional form. The multi-purpose hall on the top left, we protrude a little bit so that you create dynamism in terms of your 3D form and your 3D building. And so that in the end of the day, there's a lot of interest, there's a lot of tension you can see on the building. Of course, the workmanship can be a bit better in terms of jointing, but there's always the first try, basically. So you can see they're all in different panels and in different shapes. That's quite a big challenge, in fact. It looks as though, if you build all the greenery on the side, you look as though this building is like on a cliff. You can climb up the cliff and with all the foliage right on the rooftop. And so it's quite amazing, quite amazing sight from, if you look up from the bottom to up, in terms of 3D, in terms of its sculptural effect. This is the top of the building. On the left is the Sky Club, and on the right is the penthouses. Now we have used, in coming back to budget, this building is not cladded ACP throughout the whole building. It's only cladded around the edges, and all the horizontal sun shading, we call it the ribbons, are all in ACP. Now, and the rest of the facade is all in RC. And laminated windows. Just normal laminated bronze-colored windows to bring up the whole effect of the whole building as though it's bronze in color. So if you look up close up, you can see the various bands of horizontal ribbons in terms of sunshade. They come in flat, then after they rotate it to become horizontal, from flat surface to become horizontal, and they come in different depth to give more depth to the building, because the building is 50 stories. So if you have all your copings or your sunshade in single dimension, then it becomes a bit more flat. So you can see at different levels, we have different depth of our horizontal sun shading, which are all in aluminum ACP. The other project we have is currently Troika Kota Baru. Basically, currently, it's probably one of the most, I will use the word iconic building in Kota Baru right now, because they haven't had many high-rises there. This right smack in the city center. We have used, because the Kelantan government requires buildings to have Islamic elements in the building. So what we have done is we have looked back into our books and see how we can draw inspirations to interpret into a more modern language. So the first thing that comes out is actually the prayer, the dua. You can see our crown, the fins goes up into like that. It's actually like a prayer, like praying, right? It's praying. So basically we use that as one of the symbolism in the building. And on top of it, the crown, we crown it with a sky garden. And we used, this about 22 meters high and cladded with screens, tessellated star screens, Islamic screens, for about 16 meters. So this becomes, again, a nice place to relax for the residents. And also it becomes a lantern at night. At the back of the podium, we use aluminum screens to clad the car park podium to also comply with the 40% bomba requirement. Now, all these hoods are in RC. You can see the rope, analogy of the rope on the right-hand side, the praying rope. We allow to, and we extend the praying, the dua, the curvature of the arch in onto the facade, right? Where we allow fluidity of the building, even though the floor plan is flat, but we create fluidity and more sensual in terms of the shape through the coping. The coping comes in different depth, the coping comes in more fluid. So it gives a lot of a softer effect to the building. So if you see the building, it's quite soft. It's no longer your hard, solid corners buildings. And that's the podium on the left. We also use, again, the tessellated stars to clad the openings of the car park. Now we use the Wal Bulan. Wal Bulan has been flown in Kelantan. It's one of symbolism of Kelantan. So we stack up all the shape of Wal Bulan for the podium in terms of to ventilate the car park. It was a very successful building. It's very sought after. Currently, Airbnb, the hottest Airbnb venue in Kota Baru, and most people want to stay in this building. It's next to Hotel Perdana. Now, the original icon in Kota Baru is Hotel Perdana. Next door to it, on the right-hand side, this is our clubhouse, basically. So what we have done is, we call ourselves a little brother to the big brother over there. And we mimic to a certain extent some part of the traditional Hotel Perdana, where you see the top crown of the Hotel Perdana. We bring it back into our multi-purpose hall. At least there's some correlation with your neighbor. We respect our neighbor to a certain extent. UOB Plaza 1, we work together with Tange. I just want to show you that if you look at the building, in the daytime, it looks very solid, right? It looks very gigantic view facade because the building is three-dimensional form. It's not a straight form. So it becomes very, very dynamic in that sense. And you can see that it's very elegant and very, it looks like really a bank building, very strong in the daytime, right? Because it looks solid. And the whole building is in curtain wall, right? So we have, you can see this side and the two sides, the flanking the two sides, they're all actually glass with ceramic patterns, barcode ceramic patterns. They're all glass. The whole building is in full curtain wall, very high grade curtain wall. So, and also we integrated with sun shading for sun shading purposes for because of our tropical reasons. You look this at night, the whole building becomes a lantern because it's a glass. So it becomes a chameleon. Daytime it looks solid, but nighttime it becomes a lantern, right? And of course, if you look at different time of the year, you have a corporate color on the left-hand side, Merdeka Day in the center, and of course, Haraya, green color on different celebrations. So again, it becomes cultural symbolism in terms of how we bring our building to have certain cultural context. One more building, Lakeview, on Taman Wayu. We have 6 towers there, basically. And I'm not explaining on the building, but I just want to show you the cladding for the bridge between the towers and the podium, the car park podium. Of course, the tower, you can see fins are going out as though they are like flags or like waves or climbing up the building because of the analogy that we're next to a lake. We use very simple material, perforated aluminum panel. The one in the center that you can see are all bridges that links from the tower block to the car park podium. And car park podium, we also have vertical landscape. The podiums comes in using perforated panels with 10% porosity and 20%. And they are naturally rendered, fully protected, and it doesn't cut off your view. So basically, that's a drawing of when we send it to pass it to a contractor. And that's the section. That's the view from inside the bridge. It's actually bright, very bright, right? And there is a double layer of skin, one more dense layer of perforated skin on the outside and slightly less dense on the inside. It allows cross ventilation and also a lot of protection from rain. And that's the view, a more close-up view. It's very, very pleasant. You can look out and it's very bright and fully 100% protected. We haven't got any complaint that somebody got wet along when they come back from work or go back to the car park. And that's my last slide, Pano. We again use screens to clad our car park podium. Thank you very much.
Thank you, Jeffery. Looks like you have had a lot of fun with Facade. As a facade consultant, I must say that a lot of time when architects are having fun, we are actually having nightmare. The time flies and we are going to have our last panel discussions. It's about project management and effectiveness in the implementations of when it comes to facade. A lot of people just now have asked me, including Jeffery, like, am I the sponsor of the event? Why am I here? No, I'm not. I'm Shin. I'm from Facade Network, a homegrown facade consultancy company. I'm here today is because I was invited by Strada and Zak World of Façades. And this is my first time as a host. I've played many roles, but the first time as a host. So thank you for bearing with me for the whole day. And let's not waste everyone's time. I would like to invite CJ from Turner, Malaysia, come aboard to introduce his panelists and share with us the panel discussion topic. Welcome, CJ.
Thank you and good afternoon. My biggest pleasure to be here to talk about facade implementation and project management. I think everybody here has been going through many technical slides. You see the manufacturers are having fun, architects are having fun, and the project management is now going to struggle. So I want to invite our panelists to come to the stage. First, I want to invite Datu Izumi Hazani, please. Datu is the director of Architect MAA since 2006. He has been serving as the president of PAN in Malaysia for 4 consecutive terms from 2017 and 2022. Please. Let's give Datu a big hand. Next, I would like to introduce architect Muhammad Shafiq Sabhi. Shafiq is the head of design of architect Juriranchan, sorry. He's been working with other design firm, and his expertise in project management and site coordination for facade installation. Welcome, please. Last, not least, the youngest among the panels, let's welcome Mr. Alan Solomon. Alan is the senior project manager at Bangsa High Pavilion. And you can see his posture, right? I mean, believe it or not, Alan used to be an MMA fighter. He was the first Malaysian featured as a contestant in UFC in China as a TV program. All right. So our subject today is about, unfortunately, I want to show everybody the photos about Burj Khalifa. One of the projects I have been working with from 2004 to 2010. So you won't be able to see it, but if you have the chance to Google it, and you can see Burj Khalifa at that time already finished up to level 100, probably 120, and there's not a single element of facade. It's now the tallest building in the world, but at that time it was the tallest naked building in the world. And you might ask why? Why when the structure already finished up to that stage, and there's not a single piece of facade? So Alan, you coming from a developer, and then my understanding, facade is one of the most expensive elements other than the structure itself. If you consider about elevators, facade, or other MV elements, facade might be the most expensive. So what do you think? In your experience, what is the percentage like for your project delivery facade would cost you?
Okay, personally, every project is special, as when you're a young budding architect, you're taught to respond. So every site is different, and every site will demand a different response. There's no quick rule to saying how much I should allocate to facade. But as a project manager, now that I wear the developer hat, it's always 3 things for me: time, cost, and quality, in that order. So quality is important, yes, but it forms like 3 legs, it has to point straight up. So the moment you're off the equilibrium, that's when you start to make changes. So if the architect proposes a facade, yeah, I like it, hey, let's check it out. And then the costing comes in from my QS. I'm like, I hate to be the bad guy, but sometimes I'm the bad guy. So.
Yeah, I give everybody here a quantum. Okay, so I'm currently also the project director of Merdeka 11A. So all my career, I've been working on the tall building. So a tall building like that, facade is accounting about 8 to 10% of the entire cost. So if you talk about 1 billion job of facade, you can consider 10% of it is quite significant. So, Datu, when you are designing a building, and I think Jeffery just finished his wonderful presentation, talking about cost saving. If the client comes to you to design the facade of the building, and he it tests you about, hey, can we come up with some cost-saving options? I just want to hear every one of you, what is your knee-jerk response, or what's your normal approach to that kind of cost-saving request?
Okay, I just want to share with you, I happened to be in one conversation when people are talking about 118, the Merdeka 118, in comparison to KL Convention, KLCC, Petronas Twin Towers. They say that how wonderful that the architects today can design 118, very clean facade, and it's very cheap compared to Twin Towers, very cheap in the perception of clients, compared to the Twin Tower with all the metal cladding, everything that at one time people were saying that all the standard state in the world come to Kuala Lumpur for their buildings. But there is perception of a client that they didn't even know that cost you probably 100 million to do the facade. So most of the time, whenever we design something according to the dreams of the client, they always have a good idea whenever they travel, they see this building, or they probably Google it, and then they have a nice facade that they want to do into their building. Then we try to reach their expectation, and most of the time they will come back to you and say that, I'm going to cut your fee to cover the facade cost. So that's how they're going to save the cost on facade. So it is very challenging. So when you do not design to the expectation, then they will question your capability to design. When you design to the expectation, then they will question you, don't you have an idea how much it's going to cost to maintain, to construct, and even to get a right team, facade consultant, to help you on this. So we have to find a balance on that.
But what do you think, Shafiq? I mean, would you be able to convince your client that, hey, you save a little bit here right now, it could create problem for you in the future by selecting not so superior material? I think many people in KL, you can see some 10 years old building, you can see already some ACP panel, they are color different. It just doesn't look that nice. So what would you recommend to your client? For example, Alan, that, hey, can you not cut so many costs
I mean,
on the design?
I already said that the client should let the architects know that what is their expectation of the buildings, okay? So let's say, for example, there's a client appoint this architect. So they went to Vegas, for example, then they give this kind of reference for us to design the building, the crown or the facade itself. So we propose to that whatever they give to us. So end up, they try to cut costs again from there. They want to make it more reasonable in terms of their budgeting. So I think the conversation between the stakeholders, the client and the architects and the whatever experienced facade consultants need to sit down together and discuss the client's vision. So let's say we're talking about the mega project for Malaysia. For example, let's say we're going to have another 118, for example. Okay, so I guess the Malaysia or whatever stakeholders, they need to think of how they're going to spend the money properly. So then we can design the building to suit with their standard and expectation and how they can maintain it in the future properly. Yeah.
If I could add. Okay, so the usual way when I was a junior, the client would say, here's a piece of land, here's how much I want to sell it for, and here's the revenue that I need to meet. So the architect will usually go there, okay, here's my proposal, how do we make it fit? That's what the usual workflow is. Where I differ from my practice as a developer, once I got on the helm, I actually work hand in hand with the architect. So I will take the survey drawing, I will sketch together with the architect, we will make a model together. So it's kind of like in SketchUp, we work like a BIM model, almost. So he will do the model, I will do the model, and then we'll pass it back and forth. And in the end, we have a product that will fulfill both our requirements. That's how I look at it. So that's the difference I bring as a developer right now, because I have the capability to actually look after my requirements, and I'll hand it over to you to make the compliance happen, you know? So not a lot of developers do that, but you need to take that extra effort as a developer, I feel. So I will build a concept together with you as a, hey, I want to respond to the context like this. This view is not good for me, but this is favorable. I want to array my buildings and my units in this manner, you know? So I think this is more enriching. I feel, I don't know. Now, so the old method where the architect proposes, the developer will always look like the bad guy because I will value engineer it. Whereas my method, we're actually building something that means a lot to both of us, right? I always tell everybody, hey, these buildings are gonna last longer than we do. You wanna be able to tell your kids, hey, we built this, you know, and you should be proud of it. Instead of another pigeonhole, you know, that becomes another eyesore. So that's my humble, you know.
Very good, very good. I also want to borrow Jeffery's presentation just now. It's some very 3D dimension design, and he also mentioned, hey, workmanship might be a problem. So I want to ask that to you. When you do design and when you communicate with your client before you make the contractor a headache, a nightmare, is that constructability issue or future workman issue will be part of your consideration, and how would you overcome that?
The constructability issue is always a major issue, especially in high-rise building. Now, in terms of risk, we have to take into calculation in terms of risk. How are you going to install it? Access to the building. Sometimes you have, in the city center, you have a very tight site, construction site. You don't even have sufficient space to store the modules, the modular system, and even the crane. Sometimes you have issues as well. And that is during the construction. Further to it, you have to look during the maintenance, the life cycle of the building. How are you going to maintain it? In many cases that we experience that in terms of the additional cost for coordination, safety and health, there's always different according to the region, okay, where is the location of the project, and according to the client expectation in terms of health and safety, HSE. For example, like when we're doing some of the corporate clients, they are very stringent in controlling to ensure that HSE is a priority, so they are willing to allocate a certain budget for it. Because most of the time, if you have sufficient budget for HSE, then the contractor can probably give you a better option for the construction, even the materials, construction method. But the moment you try to cut costs in terms of HSE or the preliminary, then they have to find the place where actually they can lower their costs. So this is where actually the trade-off, they start to think about alternative materials, probably cheaper materials. Okay, because I know that the construction, the lead of the construction is the main contractors in construction site, but they will press down the price for the specialist contractors. So because they need to cover other costs, especially the preliminaries in the high rise. Most of the times when the budget was prepared for high rise building, some people, they are still looking at 3%, 4%, the preliminary cost. But in actual, if you look into the proper, it can be up to 10, 15%.
Do we have any contractors in this conference? Please raise your hand. Oh, nobody's speaking for them.
Sometimes the preliminary can be more than your facade cost. Then only you can deliver the good facade.
Okay. Good. But Shafi, you've been doing a lot of project management for facade, site coordination facade. What do you view for this? How to improve the quality of installation? Would that relate to easier design? I mean, some design, like you said, it looks nice, but it wasn't that easy to install. And when you hire a contractor, they always tell you that, don't worry, leave it to us, we can do it. And then by the time they are installing it, and there's problem everywhere. So what, from your experience, what do you think that the best solution to overcome this problem?
I mean, I'm pretty sure the coordination between the consultants, facade consultants, all the stakeholders, they need to sit down together and discuss properly. All the changes, major changes, they need to confirm at the early stage of the procurement. For example, if you want to procure facade, so we need to confirm that you're going to use that kind of material of facade. I mean, in fact, if you're dealing about the, let's say you want to have an iconic crown for a building, they need to dictate the selection of the facade, the impression of the facade properly. So I guess the I think the conversation between the client, especially, and the expected cost in the future, if they tend to change. So I believe they should have the flexibility in the budgeting, so that, and then we should allow some contingency for that changes. I'm pretty sure along the way, client feels that they may need to change the design. So I guess, like as you mentioned, so basically, the contractor may require additional fee or cost to deal with that. I'm pretty sure. Yeah.
Yeah, but Alan, you like competition, right?
Okay,
Oh, yeah,
so
we have our contractor over here.
I think this
in our previous discussion, you talked about you like you told me they kind of impressed me a lot. You said that competition breeds
excellence. That's right.
Well, in a fighting cage, yes, okay. But I'm talking about
cream rises to the top, right?
In the world of construction, let me ask you a question, right? I mean, Dato mentioned about to win, you had to lower costs. You had to you kind of shave so many things out. But if you are going to award some very significant package like facade that weighs nearly 10% of your entire project, would you? What's your option? You want to do the nominated subcontractor role, or you want to just give it to the main contractor, let him bid for it to death, and then give you the best price, and hopefully give you also the quality? What do you think?
Okay, so I'm going to answer this in a... Usually the best way to answer a question is to answer with another question, all right? How would you value engineer? So as a project manager, for the client side, I want to get value for the money that I'm paying for. So I always run a tender process. It's competitive. Competition breeds excellence. And then I give them an opportunity to VE. That's where the architect comes in to defend our stance, to look after our interests, right? But for me, to make a cost viable, like let's say you spend so much money on facade, but it's just purely facade. It's just purely to make something look good. Then to me, I can't justify that kind of cost. But however, if you tell me that facade has a monetary value, it's revenue generating. Like for instance, my project, this is a plug for my project. Go buy my project in Johor Bahru. It's called the Quayside JBCC, okay? So the facade that we spent is actually revenue generating because it's a LED facade. I can advertise on it, I can put signs on it, and it also protects from solar heat gain. So if a facade does more than one thing, it's not just aesthetic value, but it actually has a function, I'll spend money on it. To me, that's money well spent. Have that duality, you know? I remember when I was in uni and I was a kid, I was like, oh, okay, why did they make those columns huge? And then I realized the base of the columns are massive, so kids can actually sit on it. So now, it's not just a column to hold up the roof. Now it's something that can engage with the populace, you know? And that, as an architect, I want to encourage the architect to work with me to find that. Other developers be like, no, I want it the cheapest, no, you know, shave it off, don't do the extra costs, you know, like, it becomes another pigeonhole. And it just kills the soul, right? I'm going to be staring at a project for the next 4 or 5 years of my life, right? I want to like it, you know? So that is the X factor and passion I bring to the project as a developer. Go buy my properties.
Yeah, I don't know how many of you have Googled that photos showing the Burj Khalifa 120 floor without a single piece of facade. But they probably come from procurement, right? The procurement at that time, and then in many tall mega buildings, they always like to do nominated subcontractor. The reason being is the client do not want the main contractor to add markup on this significant project. So they believe if I buy it myself, I get the most competitive price, and I give you 2, 3, 4, 5% profit attendance to their job. And then in this process, your quality is maintained because I select the good facade contractor in the market. And I save the cost because I try to beat it down with all these contractors. And then I nominate to you. It's like a arranged marriage, right? And then normally don't go very well. But I want to ask Dato about your view on this one. Do you think that the nominated subcontractor is the best way to control the quality of the facade installation, or you believe there are any other way in your experience they can also serve the same purpose?
I think, okay, of course, if I want to make my work easier, I just put everything under the main contractor. So that the liability will go to main contractors.
You will pay for convenience.
But, of course, if you want the best, I still believe that you still can make an arrangement, but the contract, the arrangement between the NSC and the main contractor must be very clear. Where is the boundary of responsibility of the main contractors? Because we don't want when the NSC start to accuse that I cannot proceed with the work because the main contractor has not prepared the section of work, or maybe the surface is not ready for me to install my facade. There's always this kind of argument. They start claiming for the extension of time and losses and so on. So we want to avoid that. In terms of work, if you have the specialist contractor as NSC and they can be responsible for that, that will be okay. But if they try to push back and the contractors will take the opportunity to claim for delays, then that is not a good contract situation. So that's why we have to be very clear if you want to do that. If you want to avoid it at all, then put everything domesticated, the especially contractor under the main contractor. But I like what I want to respond to what Alan mentioned just now. That
Alan, be ready.
I start to like to meet more clients like Alan. Yeah. You are willing to spend money as long as you get the future benefit or future money. For example, you mentioned just now that your facade is revenue generating. So sometimes when we try to explain to the client that whatever you invest today, you probably need to spend a little bit more today, but you gain the benefit for the long run. As one of the example, the Daya Bumi complex, it was constructed in 1978, completed in 1984. So if you notice that there's a lot of mukhanas, they call it mukhanas, is Islamic geometric pattern around the building, wrap the building. It was never been cleaned because they use the self-cleansing technology. So the building owner probably invests a little bit more doing the testing with the Japanese contractor at that time. I think the consortium of Shimizu doing a little bit more, okay, testing everything so that the best result, so they save the long run 40 years maintenance cost on that. So this is what we want to explain to client. As long as a client like Alan can open a little bit door, okay, usually they don't care to spend a little bit more on their own project. But for the project that they are going to sell, most of the time clients say, I don't care because I want to be responsible only for 2 years. After the defect liability period, then everything is not my responsibility anymore. So this kind of perception, mentality, probably we have to change. Otherwise, we cannot achieve a sustainable city and how the building can sustain our environment, our weather, and we don't want that one day our city become a sick city with all the dilapidated building and so on.
You touch based on the window cleaning, right? Burj Khalifa's in Dubai. You know, Dubai rains 3 days a year, and Malaysia rains 3 times a day. So, do you really think glass facade and a unitized panel, I mean, you look at Tun Razak, I mean, KLCC, is that really an ideal design for in this kind of climate? Shafi, what do you think?
It's quite hard because, I mean, I guess we try to fight with other countries. So they have like glass facade all over the states, I guess. So we also tend to have that kind of visualization of buildings. So, I mean, I feel that we may need to adopt with the glass facade and to make sure it suits with the current climate in Malaysia. I know it's quite challenging having the glass facade, high rises in Malaysia with, I mean, you can have like daily raining, what's not right. So basically, I think we should invest and we should think of how to have it properly in Malaysia. Yeah.
What do you think, Dato?
Me?
Yeah.
Okay, so sorry, I missed the point.
I'm just asking that, do you really believe the fully glazed facade curtain wall design through this kind of weather? I mean, it was okay in Dubai because it doesn't rain that much, right? You clean the glass, you hire Tom Cruise to do Mission Impossible. You only had to do 1 twice a year. But I use our project for example, right? We have like 150,000 square meter area of glass in Merdeka 118, 18,000 pieces of unitized panel. And we have 7 BMU to do that, to clean the glass. And you look at Tun Razak, they're probably doing the same, but they're doing this non-stop. Guess how, every piece of glass, how many times they got cleaned a year?
Maybe every 6 months, so they have to do it all around the year.
in the perfect world, it got cleaned 4 times a year. So what I'm trying to say that do you see there are any other options that instead of fully utilized glass facade, they are the different design, and they can also cater the tall buildings requirement?
I think glass building is nice, very nice. I love glass buildings. I can deny that. Okay, it's okay to have glass building, but we need to have more research, okay, on the development of glass, probably with nanotechnology, so that I hope that one day we can have glass that we don't need to clean anymore, or self-cleansing glass.
Yep.
And I believe that it is possible. It's not something that impossible, it is possible. So just that I think we have a lot of researchers or even our facade consultant here propose to us, propose to the industry, a new technology that where actually we can have that kind of glass.
Well, hopefully next year in this conference we can see something like that, being presented. What do you think as a developer? Do you think maintenance to the skin of the building is on top of your priority, or?
My gosh, the cost of a BMU scares me, man, in every single project. So, like for my projects, the moment you factor in a BMU, you have to factor in the rails, you have to factor in the support structure, and suddenly my building's heavier. You know what? Let's encourage the sport of rock climbing, so let's put abseiling.
Absolutely, yeah.
So, I mean, it gives all those guys who loves the heights, right, something to do, I guess, but I don't know. I'm open to new technology. Like, since you're talking about new methods and new technology, let's talk about how we can use parametric modeling, how we can use AI, maybe. That is the future, and how we can find new methods of running a building, It's always the post and beam, it's always glass and glazing, right? There has to be new ways of doing things. So now everybody's doing the greenwashing thing. Let's just put green stuff on it and call it the green, right? When I was in uni, it was Ken Yang. I was like, oh, Ken Yang is from Malaysia. I was like, yeah, that's my country, And then we were, we were the green generation, so to speak. And back in the day, it was deconstructivist, correct? So now we're smack in the middle of greenwashing everything now. But how green is green? And can I use green to minimize glazing? Can I plant trees in every single story just to block the solar gain? And if I do, how deep do I have to make it? Is it practical? The depth of the roots and all that. So, hey, architects are creative, right? Let's find something out together. Every single building is a prototype. So I view every single building as an opportunity to experiment. When you finish a project, what have you learned from it? That's what gives it value. Then your next project, you can take it the next step. That's how evolution and adaptation is done, I guess.
Yeah,
I humbly feel. I don't know. That's just me.
And that is one of the craziest idea that I believe that if we can do in future, because you see that today some designers start to do like a kinetic facade, very dynamic. The facade can be changed. I was thinking that probably one day we can look into how to flip the glass. For example, this year the glass will be outside, and next year you can flip it, become inside, so you can clean from inside. You don't need the BMU anymore. You clean from inside. It's reachable. It's reachable to flip the glass. It may not happen in 10, 20 years, but it is possible if we really want to do it. If you look at how some building in China, even in Singapore, with all the kinetic change, and I think David Fisher did the building, rotating building, so that you can have a different form of the tower at different time. It is possible. Just that probably we need to put more effort. If I can flip the glass every panel once a year so that I can clean from inside, that probably I can save your BMU cost.
So you see, architect is not only creating nightmare for us, they also try to save job for us to clean the glass. But experiment one thing, but the actual product, right? I mean, we had nice design, you probably hire a contractor, but my observation in Malaysia, when this 18,000 panel being installed, inspection on site seems to be an issue, right? I mean, construction food chain is that you have main com, subcon, main com, subcon, sub. At the end of the day, it's a group of, I don't know where they're from, installing the panel for you. So, Shafiq, what do you think that if the client, because in Malaysia, the client had to hire for COW, for inspection, and if you cut down costs on that, you don't monitor the entire installation, some gasket, some seal got broken, you never notice that, and then you will see the water coming through from there in the future. So from your experience, project management experience on facade installation, what do you think, what kind of strategy that you can mitigate this and improve the QA, QC of quality management on site?
In my opinion, basically, the first thing is the delivery of the materials. So you need to get the right staff. I mean, I believe we discussed it before, the permanent staff, so that to make sure the quality of product is the same what will be delivered to the site. So, I mean, I guess that's the first stage. So, secondly, it's like you need to hire the right guy, for sure, with a lot of experience to make sure the facade being installed properly. So, of course, the early coordination in terms of design, of course, you need to be tackled before that. So, of course, I mean, the idea of having additional things on top of that is highly not recommended. I mean, such as once you have a VE, so you have money, okay? So suddenly you think of having a facade lighting, okay? You have money, so you want to have facade lighting. So yes, you can have the facade lighting properly, but end up you can't hide the driver of the facade lighting, because you don't have space to hide the driver, so you make the facade looks bad a bit. So for me, this is when the designers, the architect, or the RA, I guess, need to advise during the construction where we should avoid this kind of ideas of having additional things. So yeah, that's my thought. I mean, the facade lighting is the easiest way to utilize the VE money. But of course, you have challenges in terms of installing driver, and you need to drill the hole on the facade, and then you have an issue like water seepage. So I think we should not have that. We should avoid that. Yeah, coordination, I guess. Yeah.
So about staff, I just want to add something here, CJ, if I may. Sorry for interrupting. Okay. When it comes to site staff and site implementation and taking care of QA, QC, or even just making everything uniform and consistent, I think the word consistency is important. I find when I was an RA, when I was a young architect, like being on site and just how do I gauge something is acceptable to the end user? Because you're responsible to the end user as an architect, right? So now I'm an RA, what do? I find the easiest way to do it is just make a mock-up. Okay, let's do a mock-up. Let's you accept. Everybody signed off. Everybody agree, and I'll just use that and as a base measuring tool. So if your site agent can just follow this simple methodology, I think consistency can be achieved. Because the moment it deviates, you say, "Hey, mock-up's over here, man." It's not looking like the mock-up right now. So I think it leaves very little room for arguments. I feel anyway. I don't know if there's a newer method. Maybe I'd like to hear about it. But in standard industry practice, it's always mock-ups before you go the whole building, right?
Yeah. Well, definitely, all architects were specify mock-up. I mean, there are performance mock-up, there are static mock-up. I would probably tell you that static mock-up installed on site were probably the best at the time. But once they come into the actual building, the key issue here is how to maintain the quality. As I already explained, in this industry local here, the actual installation is coming from those subcontractors. They probably might not be properly trained. On the other side of it is the supervision. Yeah. That we talked about this before. That you feel comfortable that you just hire the inspector from the street. Most of the architects in town do so, or even hire a resident architect. and then to ensure your design intent, your quality, where it's coming from yourself or your facade consultant to do that? I mean, do you have a strategy to make sure that the design is properly implemented on site?
Even, pardon me for saying this, in reality, in the construction industry, even the consultants, we have like A, B, C, D, E, okay? So if you are prepared to pay for A, then 90%, 99% you can get the good quality, okay? So that in terms of supervision, construction quality, the contractor coordination, even the project manager. Okay? But if you are not prepared to pay for that, if you expect to get the quality of A, but you are prepared to pay for C and D, there is the major problems going to happen. Okay? No matter how long that your site supervision stay in the office, in the site, okay, including the overtime charges, but he may not pick up the right things. He may just be there claiming overtime. So that's why I say that the most important that you choose A, B, C, D, or even worse is E. So your site staff may not be at the site at all. So that's why I think it's not that we do not have, okay, this capability here. We have the capability here. We have good project manager, site supervisors, contractors. We have a good contractors. We have a good set of consultants. But are we willing to go for that or not? Okay. So that's why I think, depending on the risk, I always mention to the client that if this building is high risk, and then don't compromise on this, because you will get the worst situation that at the end you probably have to spend more money to rectify the damages, the defect, or whatever non-compliance to that. So that's why if the client want to save money on supervision, I don't think that's the right thing to do. Yeah.
So, Alan, how do you get A's through competitions?
Oh, from my side, there's always going to be COWs and RAs and REs, man. I don't cut that corner. You know?
Sure.
So I indemnify myself. So if something goes wrong, I can just look at the consultant, man.
Yeah. Okay. So we look at again. I was with Alan's presentation. So, Doctor, what do you think right now nowadays the BIM implementation? Because facade is a scheme of the building that you need a lot of coordinate with structure, MEP, other stuff. What do you think the usage of the BIM in Malaysia's architect design industry? 80%, 70%? What do you feel right now?
I think at the moment, in terms of percentage of adoption of BIM is still very low in Malaysia.
So you still believe it's very low?
But, okay, I like to say that it is very important for you to start to adopt, for those who have yet to adopt BIM. As you see some of the presentation just now, it's not just the BIM. They're talking about parametric. There's no single component, so repetitive. It's every panel, every component is unique by itself. You even need to barcode for arrangement with numbers, everything, installation at site, so that you can track where is the panel now and which floor, which section. So it is impossible to do it manually or to use the 2D CAD. I think the previous speaker talked about Grasshopper, talk about Rhino, this all the parametric software, parametric application. And being clients, they want to be outstanding. More and more clients start to demand, I think since early 2000, in Dubai, everybody want to be iconic, And now clients want to be more outstanding. They're asking for more and more. So if you are stay on the conventional CAD, then I don't think you are going to be competitive, and very soon that you are going to be dinosaur. Okay.
Jeffery, what's your friend percentage while using the BIM implementation? I mean, especially you have to talk to other consultants like MEP or structures.
So I mean, talking about the BIM for construction, of course, from the BIM itself, we can do the costing straight away from the BIM. You can know the initial costing from the BIM itself while doing the Revit. That's a good thing. So we can use that information, give back to the client saying that this is the cost, the expected cost. So from there we can have, like, as we mentioned, proper coordination with the BIM. during the construction, we have all the bus coding, everything properly. You know all the deliveries. There's a system for that, I'm pretty sure. So same goes to facilities maintenance, I guess. So we can use the information from BIM, Revit, to be part of the documentation for facilities management. So you know that where you need to change the facade or when you need to repair or rectify for every 5 or 3 years, that kind of thing. So that is why I believe BIM can contribute to that kind of situation properly. Yeah. So in Malaysia, I guess my firm currently, they're using BIM for hospital project because hospital is quite complex. So I guess using BIM for facade maintenance, talking about maintenance, I think it's really, we really need that kind of situation. I mean, implementation for it. Yeah.
So Alan, from a developer point of view, would you, in your future project, right, would you like enforce all your design consultant, the BIM to be, even from the main contractor, right, the BIM to be part of their scope?
Okay, so not just for future, but right now, all my projects, 100% everybody's on BIM now. There's no exceptions. Number one, it reduces my risk of VOs. The clash detection is done almost every 1 week, every 2 weeks. We always meet and say, hey man, your pipes are going through my beams or I need ceiling height. I detect this now because I remember when I was an RA, I was like, oh my gosh, the hospital project, it's only 1.8 meters ceiling height, nobody's gonna clear this and I have to solve it on site. So as the RA, you gotta sketch and dude, it's a headache. So solve it now and nip it in the bud in the early stages in BIM, right? But where I wanna take BIM now, I wanna experiment this in my next job, is that instead of just using BIM, you save the model, you have that model, right? Now, I wanna put it into AR. So I wanna put okay, so the column, I'll configure it where there's a QR code, I use my phone and I put the AR, and now I can see what it's gonna build, what it's gonna look like when it's built. It's very easy to do. It's just a matter of just coordinating those QR code locations and just pinning it in. Not done that yet, but I don't know how much is the cost. Everybody hates that word, but I'm looking at it right now. The moment you have a BIM model, it's very easy to adapt it, because the hard work is already done, right?
The technology is already here.
It's there. Like I'm playing games with it, right?
Yes.
You just put the VR and then
So it all come down to the cost of how much money you want to spend.
Okay. For those who are, actually I don't want to mention this in front of Alan because he's a developer. If you use BIM in the consultant, architects, engineer, actually you can reduce your cost, operational cost. Many people may not realize that because they say they have to pay for the hardware. Hardware investment is a lot for 3D, for BIM, and the software as well. But in terms of resources, other resources, the human resources, you probably can reduce by 80%. If you use the usual CAD, you probably need 5 people to do one building design, the standard one. Let's say a 20-story simple building. You need 5 people to do elevation, section, the plan. With BIM, you only need 1 guy to do 5 or 6 workload of other people. So that is how actually we save costs on that. What you must make sure that the project that demand BIM or the project on BIM, or you have to operate on BIM all the time, and then the project has to come all the time. But if you have a gap, pause, then your machine is idling, your BIM modeler is idling, then it's going to be costly. But if you continuously utilize that resources, it can be a lot cheaper.
What do you think?
I agree with Resume for sure. So yeah.
So if let's say next year you come to this conference, I think we only have like less than 2 minutes. So what do you like to see new in this conference? Ellen, what do you think?
Man, show me ways to do VE, baby. I'm open to all avenues of value engineering and to get the most value for the money. But bang for the buck, they say, right? So, it's not just for the project, but it's also for the end user. I'm selling you something that's quality for an affordable price, right? Yeah. So, the firm that I operate in, we're not the biggest firm in Malaysia. We're actually very, very bespoke. So, because we're small and we're bespoke, I get the opportunity to really create products that we can be proud of. And I think when you're too big, there's a tendency for bloat. So now that I get to run the project team and I get to run it the way I like to add value to it. If there's always a cost, yes, but can I justify the cost?
Sure.
So I think the way forward is, hey, if you can do it in VE, then, you know, sky's the limit, baby.
How about you?
I wish we can have a menu so that all the developer can choose. I want a fun fries, I want more tomato, extra. So in a way that whenever the developer or any developer want to engage architect, they can tick. I want facade, I want theme, I want this. At the end, at the bottom, you see the price.
Cost.
You see the price. So instead of, okay, I want this, but I want everything. So really something that I hope that the industry or even the professional board can look into how, because the architecture services, engineering services has expanded more and more. Okay, it's not like conventionally you practice, you just do one building plan and then you submit to local authority. It's not like that anymore. Inclusive, there's more convergence of more services. It's not just drawing plans anymore. Sometimes you have to include the facade lighting, facade services, or even human management, traffic flow, fire simulation, fire safety simulation, analysis, and so on. So this is where I believe that if the industry can look into how that the developer or the client can tick off the menu, what they want, and then the price come at the bottom. This is the price you should pay.
Perfect. One wish. What do you want to see next year?
I mean, I wish that I wish that architecture firm could hire facade consultants in their office for a big company. So at least we can have our own in-house facade consultants and in fact our own engineers to deal with the facade. So it's made life easy for the developer, I guess. Yeah.
All right.
Yeah.
Very good. We are kind of only 1 minute
not too
overrun,
bad,
right? Not too bad as a project manager, managing such a complicated conversation. Thank you, everyone.
Thank you.
And I hope the audience has enjoyed our discussion. All right, thank you.
Thank you.
Thank you, everyone. It was such an informative sessions. Thank you. I think that's enough photo for today. Thank you, Jaka. And thanks everyone for joining us today, and truly appreciate everyone's contributions. They have shared about their experience, the products and everything. Thank you, and see you all again in our next editions. Thank you.